All right, my friends, we've gotten through quite a good amount of stuff around the kind of internals of Node so far. We're now going to move on and we're going to start looking at some way more practical knowledge. So we're going to start working with a real project and adding in some pretty advanced Node features around it. I hope that you've really enjoyed the kind of performance discussion so far. It definitely was some interesting stuff for me personally to kind of put down in paper. Definitely a good experience. Anyways, let's get to it and talk about exactly what we're going to do for the rest of this course. So here's a plan. This is an advanced course, and if you're here, you probably don't want to put together another Hello World application. And heck, probably even the Express application we already did was kind of boring for you. So I don't want to have to waste any of your time putting together really basic Express applications or doing a bunch of boilerplate setup. So to get through some more advanced features rather quickly in this course, rather than doing a bunch of very boring default boilerplate setup, you and I are going to clone an existing plain Jane node.js application. This is going to be an existing application that we are going to clone onto our local machine. It has just a little bit of basic routing setup and a little bit of basic authentication. We're then going to take that kind of pre-done package and we're going to add in some pretty advanced features to it. And at the very end, we're going to end up with a pretty cool application. Again, I'm doing this just to make sure we can skip that kind of more boring stuff. If you're kind of disappointed to hear that and you're thinking, man, I would really like to put this application together totally from scratch, I do have another course called Node with React. And the end result of that course is more or less the boilerplate that we're kind of using here. So if you really want to go through all this stuff 100% from scratch, you can go check out my other course, build the application inside there, and come back to this one. And the application that we're going to work with right here is pretty similar to what we end up with in that last course. Okay, so with that in mind, let's continue in the next video. We're going to clone this project and we're going to get a really good idea of all the code that exists inside of it right now, and we'll start adding in some pretty awesome features. So quick break, and I'll see you in just a minute. In the last section, we spoke about how we're going to be working from a starter boilerplate project that already has a little bit of Express code written inside of it. In this section, we're going to clone that project and start to walk through some of the code inside of it. Of course, it's definitely key that you have some reasonable idea of what this boilerplate project is doing for us to be able to effectively say, test it, or add in data migrations, or anything else here, right? So we are going to do a little bit of a walkthrough on this project. Let's first start off by cloning this project to our local machine. We'll then be able to walk through the code inside of it. So here's a link to the GitHub repo where the starter project is hosted. So github.com, my name, Advanced Node Starter. I'm going to open up a new browser tab. I'll paste that link in and I'm going to visit that repo. All we really want to do right now is clone this repository. So once this repo appears, I'm going to find the clone or download button off here to the right hand side of the screen. I'll open it up, copy the link, and then I'm going to change on over to my terminal where I'm going to use git to clone this project to my local machine. All right, so over at my terminal, I'm going to clone the project by writing git clone and then the link itself, like so. So I'll run this. I'll then change into that directory that was just created. So the directory is Advanced Node Starter. And then I'm going to start my code editor up inside of that directory. All right, so we're also going to be installing a couple of dependencies here for this project as well. Let's not forget that we have to do that. But like I said, let's first start off by doing a little bit of a code walkthrough. All right, so off to the left-hand side of my screen, you'll see some of the different files and folders that are included inside this project. This is a pretty typical Express application. I have really not done anything too crazy here. Everything is kicked off from the index.js file. So this file hopefully will look somewhat familiar. At the top, we are requiring in a couple modules. We register a couple models with Mongoose. We set up Passport for handling authentication. We set up our Mongoose instance. We create our Express application. We set up a couple of pieces of middleware. We register our event handlers. We set up some production file serving, and then finally our app actually starts listening on some given port. I know I might say that this is not anything too crazy, but that definitely seems like a pretty good amount of code. So rather than walking through all this code and reading it line by line, let's take a look at a diagram that's hopefully going to help us get a little bit better understanding of what's going on with all this code. All right. So I put together a diagram that looks very similar to the one that we just looked at a moment ago. All right, so here's the diagram in total, but it's been customized to reflect all the different parts of the actual project that we're working with. So we're going to do a very similar walkthrough to our Express server like we did just a moment ago, but this one has been tailored to the code base that we just cloned. All right, so let's zoom in. There we go. Okay, so again, we start off here in the browser. The project that we just installed is not only an Express application, it also has embedded inside of it a Create React app installation as well. So there is a single page application app included in the project that we just cloned. Now, as a quick aside, if you're not familiar with React and you've never worked with it before, don't sweat it for the purposes of this course. We're going to be working with React just a tiny bit to set up a little bit of file upload stuff later on. But definitely React knowledge is not a necessity here by any means at all. So there is a Create React app project inside of here, but everything else is definitely Express and Node related. So when that Create React app boots up, it might make some type of request to our backend server, the one we just cloned. So we get some type of incoming HTTP request, which flows into a couple of different middleware that are already installed and wired up inside of this project. There's the body parser middleware, which is used for parsing the body of post requests that come into the application. There's a cookie session middleware that handles authentication and maintenance of sessions for incoming requests. And there's also a passport middleware wired up as well. Passport is intended to handle authentication inside of our app. And this passport instance has already been wired up inside this project to handle OAuth through Google. So that's how our application is going to be handling authentication. It's all wired up using OAuth through Google service. There's then two groups of routes inside of our application. There's one group of routes for handling authentication, so for kicking off the authentication process, and for logging out, and similar operations to that. There's also a set of routes for handling a resource called blogs. So that's the primary purpose of this starter project that we just installed. It's all about handling blog posts. So creating blogs, listing blogs, showing blogs to the user, pretty much just a very basic resource. Now, that might sound like a pretty boring application, right? Like it's another blog application. Well, to be honest, the app that we just installed and the work that we're going to be doing with it is really not quite so much around this actual resource, and we're really going to be focused around a lot of the code around it. So this application, not quite so much about making some like fancy app with sparkles all over the place. It's really much more about understanding the code behind the scenes. So honestly, working with just blogs as a resource inside this application is really going to be for the best. Trust me. There's one other piece of middleware that I want you to be aware of, and that is the require login middleware. So for any user to get access to any blogs or to create blogs or do anything with them whatsoever, they must be logged into our application. And we'll definitely see that in action very shortly. Now, both the auth routes and the blog routes that are set up inside this application make use of Mongoose models. So all of our data is going to be stored inside of a MongoDB database. There are two models that have been created already inside this project, one to represent a user and one to represent a blog post. And we'll definitely see those in action. So after some request comes in, it will either be handled by our set of authentication routes or blog routes, and then eventually we formulate a response and send it back to the front end of our application. So now that we've got a better idea of how this project is put together, let's install a couple of dependencies to the project, and then we'll be able to actually run it and test it out inside of our browser. So I'm going to flip back over to my terminal where we're going to install these dependencies. Inside of the root project directory, I'm going to immediately run npm install. Now you will recall, as I said just a moment ago, that there's also a React project embedded in here as well. So we have to also install dependencies for that project as well. 2 sets of dependencies. I'm going to open up a second terminal window, also based inside this project directory. So any second here. Come on. Waiting for this thing to pop up. All right, let's just let it do its thing. There we go. Okay. There we go. So inside this project directory, you'll see a folder called client. That's where the React app is placed. So I'm going to also change into that client directory, and then I will run npm install in here as well to install dependencies for that React project. Like so. Okay, so 2 sets of dependencies. Those are going to take a little bit to run. So let's just pause right here. We'll continue in the next video and start making use of this project, actually run it, and get a sense of what it's really doing inside the browser. So I'll see you in just a minute. In the last section, we cloned our project and installed a couple of dependencies. Let's now start the project up and visit it inside the browser. I'm at my command line again inside of the project directory, and inside of here, I'm going to run one command to start up both the node server and the React application as well. And that command is npm run dev. So I'll run that and I'll give it just a second to actually start up. So again, this starts up 2 separate processes, both the Express server that's serving as our backend and the React application as well. The React application is going to attempt to automatically open up a new browser tab and visit localhost 3000, which is where the React application is available at. Now, if it does not open up a tab automatically, then feel free to open up your browser yourself and navigate to localhost 3000. Once you do so, you should see a screen like this appear. So this is our application, or at least the React side of it. At the top left, you'll notice we've got the application name, and on the top right, we've got a nice big button that says Login with Google. So again, we're using Google OAuth to handle authentication inside this project. Now, one thing I want you to be aware of right now, the application, as we just started it up, is connecting to a MongoDB instance, but it's connecting with a read-only account. I put that MongoDB instance in here automatically just so we could easily start up the server, but it's configured in read-only mode. In other words, if you try to log in right now, the login process will fail. So we do have to connect our own personal copy of MongoDB here. I'm going to flip on over to my code editor, and I'm going to find the config directory. Inside the config directory, there's a couple of different files inside of here for handling different keys related to our project. So like database access keys, and keys for encrypting cookies, and keys for accessing the Google OAuth flow. Right now, our project is running in development mode. So all the keys that are being used are defined inside of the dev.js file. Let's open that up. Inside of here, you'll find a Google Client ID and a Google Client Secret. So these are 2 keys that are used for the OAuth flow inside of our application. We're going to replace these keys in just a moment with your own personal set. So you probably don't want to use the ones I put in here. You probably want to use your own set of keys. In addition, you'll also notice the Mongo URI. So this is the read-only database that I set up for you just so you could start out the project easily. So we're going to have to also replace this URL right here with some customized link for just you, just your own personal copy of MongoDB that only you can access. So with that in mind, let's continue in the next video. We're going to take a little bit of time to generate a new MongoDB instance and put that new URL inside of here. And we'll do the same thing for the Google Client ID and Google Client Secret as well. So I'll see you in just a minute. In the last section, we spoke about how your project is currently using some default keys, and we probably want to replace those with your own personalized key. So we're going to first start off by creating a new instance of MongoDB and wiring up our application to use that. Now I'm going to show you how to create a MongoDB instance through a third-party service called imlab.com. Imlab provides free copies of MongoDB that you can very easily connect to. If you already have MongoDB installed on your local computer and you know that it's already properly configured, you can absolutely use your own local copy of Mongo. That's totally fine. But I'm going to show you how to use Imlab just because it is much easier to get started with if you have not already set up Mongo on your local machine. To sign up for MLab, I'm going to flip on over to my browser. I'm going to open up a new browser tab, and I'll navigate to mlab.com. Once here, I automatically get kicked to the dashboard because I've already signed up and logged into an account. So if you've never used MLab before, that's totally fine. You can click the big blue sign up button up here at the top right-hand side and sign up for a brand new account. After you do so, you'll want to log in, and you should see that dashboard appear on the screen. So this is a list of all the different MongoDB deployments that I'm already running. I'm going to create a brand new deployment to use inside of our application. So on the top right up here, I'm going to find the Create New button. I'll click it, and I'll go through this wizard to create a brand new instance of Mongo. Now we should not have to be paying anything for this Mongo instance. It should be 100% free. So on the left-hand side, you'll want to find a plan type that says something like Sandbox, and it should be very clearly labeled as being free. I'll click on that, and then click on Continue on the bottom right. I'll then select a region. The region here doesn't matter too much, and you'll notice there's only 2 here. So if you're located in somewhere on the planet that is very far from Virginia or Ireland, that's totally fine. Just pick whichever one is closer to you. So for me, it's Virginia. So I'm going to select that one. And then I'll click on Continue. And then finally, I'm told that I have to enter a database name. So for my database name, and I really recommend you use this same name as well, I'm going to enter in blog_dev, like so. I'll then click on Continue and Submit Order. So that's going to create my own personal copy. And you'll want to use your own copy rather than the one that I already wired up to our project, because again, that is a read-only database, just so you can run the project. So after a minute or two, we'll see this new database wizard resolve. And then on this list, I should see the new database that I just created. So here's blog_dev. I'm going to click on that link. And before we can use this thing, we have to do one last step, which is to create a database user. This is an account that is used to actually access the database itself. I'm going to find the Users tab right here. I'll click on it, and then on the bottom right-hand side, I'll find the button that says Add Database User. So I'll click on that button, and I need to create a new username and a password. Now this is a development account, so you don't have to be too crazy with security here, but of course use some reasonable username and password. So I'm just going to use Steven and password, like so. And then I'll click on Create. Once that's done, I can now take the URL or URI that is listed up here towards the top, and this is kind of small text, so let me zoom in. I'm going to take this URL right here, and this is what we need to actually add to that keys file that we were just looking at. So I'm going to select this link right here, I'm going to copy it, and then I'm going to change back over to my code editor. I'm going to make sure I'm inside of my dev.js file. I'm going to find the Mongo URI string. I'm going to delete the existing one, like so. And then I'll put in the link that I just copied. Now one last thing here. We have to replace the DB user right here and the DB password with the credentials that we just created. So that's going to be the credentials for this user that you just made 2 seconds ago. So I'm going to enter in my username of Steven and my password of password, like so. Cool, so that looks good. If I now change back over to my terminal, I should see a message that says that the server just restarted because I just changed that keys file and saved it. Anytime we change any file inside of our project, the server is going to automatically restart. So now, if we visit our application inside the browser again, we should be connected to our own personal copy of MongoDB. Let's go to the browser right now and test that out. So I'm going to go back over to localhost 3000. I'm going to refresh the page. And then on the top right-hand side, I'm going to click on that Login with Google button. So we should now be able to log in with Google because we have a database that we can actually write to. Anytime we try to sign in with Google, it's going to attempt to create a new user record inside of our database. And before, when we had that read-only database that came with our project, that write action would have failed. So now we've got a copy of the database that we should be able to write to. so we should be able to log in just fine. So I'll click Login with Google. I get asked to select a Google account, so I'm just going to pick some random account here, and then I'll actually get redirected back to my application. Back over here, you should now see the header looks slightly different. So I should see something that says My Blogs and an option to log out. And I should also see a red button down here as well. Cool, so we just signed into our application. Let's pause right now. We'll come back in the next video and we'll continue doing a little walkthrough of this application, and then we'll get started on our first big feature that we're going to add to this app. In the last section, we configured a new copy of MongoDB and wired it up to our application. We can now walk through the entire front-end app and get a good idea of what the entire app in its entirety does for us right now. After we have a really good understanding of what it does, we're then going to start adding on our first advanced feature. So the first thing I want to do is use this UI right here to create a brand new blog post. Remember, that's pretty much what this application does. It creates blog posts and shows them to the user. Pretty straightforward. To create a new blog post, I'm going to click on the red button down here to the right-hand side. I then get prompted to add in a title for the blog and some amount of content for it as well. So I'm going to add in a blog title of my first blog. And then for content, just to get some like realistic content here, I'm going to copy some lorem ipsum text. There we go. So I'll click on next. I get asked to confirm the entries for my blog post, and then I'll click on the Save Blog button. That then redirects me back to my list of blogs, and I can see that blog appear on the screen. I can click on Read right here, and it will give me a detail about that particular blog. From here, I can either click the back button or click on simply My Blogs to go back to the list of blogs. So really, I can't say it enough, it's a pretty straightforward little app. Now the last thing I want to do is attempt to log out of the application. So at the top right hand of the screen, I'm going to click on the Log Out button, and that's pretty much it. That's all there is. So in total, there's a handful of routes that we need to be aware of that are running on the Express server right now. So these are the routes that I want you to be aware of. The Express server serves about 7 different routes in total. There's a section of routes that all handle authentication, and we saw those on this diagram over here just a second ago. So all these auth routes right here. And there's also a section of routes that handle working with blog posts as well. We've got a couple of routes right here, or at least the first one, that starts the OAuth flow to log in with Google. We've got another route to handle the callback for the OAuth flow, and we'll talk about that OAuth flow quite a bit later on in the course. We've got a route to log out, which we just used, and we've got a route to access the currently logged in user. For dealing with blog posts, we've got one route to get a blog with some specific ID. We've got one route to get a list of all the blogs that belong to the current user, and then one to actually create a new blog post as well. One thing I want you to be aware of is that there's no sharing of blog posts inside this application between different users. All the blog posts belong to one specific user. So if you create a post, it's only visible to that person, and it's not visible to anyone else in the app. Just so you know where this code is located for handling all those routes, I want to show you back inside of our code editor, the routes directory. So inside the routes folder, you'll find 2 files inside of here. One is called auth routes and one is called blog routes. So as you might imagine, blog routes handles the 3 routes that are dedicated to finding or working with individual blog posts. So we have one route handler to get a single blog, one route handler to get a list of all the blogs, and then one to create a new one as well. And if you want to, you can certainly feel free to go through the auth routes as well, but I think you get the idea of how this routing is set up. Okay, so I think that overall, we've now got a reasonable idea of what this application does. We haven't really looked at all the code that is running inside the project, but I think you've got the general gist. It's an Express application. It handles authentication and blog posts. There's a React app that is used for the front end, and that React app communicates with the Express server to eventually show some content on the screen. That's really all we need to know for right now. Let's continue in the next section, and we're going to start to talk about the first big feature that we're going to add into this app to really supercharge it. So I'll see you in just a second. I think we've got a reasonable idea of how this application works. In this section, we're going to begin working on our first big feature that we're going to add to this application. The first big thing that we're going to add in is something called caching. Caching is a very easy way to dramatically improve the read performance of an Express application that makes use of MongoDB. Now, caching can be used with any type of database, any type, but we're going to especially be focusing on caching with Mongo. To give you a good idea of what caching is for, I want to show you some details about what happens whenever we load this application inside of our browser. I'm going to open up my Chrome request log. So over here I've got the network tab selected, and I'm also going to filter by XHR requests. I'm then going to refresh the application, and let's take a look at what happens. So as you'll see, there are 3 requests that pop up here. The bottom one that says info right here is related to the React server that's actually running for us. So that's not really relevant right now. However, the other 2 are much more relevant. You'll see one right here called blogs. This is a list of all the different blogs that belong to the current user. You'll also see a second request here called current user. So this is another request that is made to figure out who the current user of the application is. Let's take a look at how these requests are made in a diagram format, and it'll give us a better idea of exactly what's going on behind the scenes when these 2 requests are issued to the back end. Okay, so here's our diagram. The first couple steps here aren't super important, but I listed them out just to be complete. So everything starts off when our browser first visits localhost 3000/blogs. The React app loads up in the browser. The React app decides to make a request to the backend to figure out who the current user is and also retrieve a list of blogs that belong to them. So the request is made. That request is received by our Express API. Express takes that incoming request, one for the current user and one for the list of blogs, and sends each request off to the respective route handlers inside of our application. Those route handlers see those incoming requests, and then they make use of our Mongoose library to reach out to MongoDB and retrieve some amount of information. So Mongoose reaches out to the Mongo database that we just created, fetches some amount of data, and returns it to the Express side of our application. The Express app then takes that data and sends it all the way back to the React app, where the React app then uses it in some fashion to render the page on the screen. Let's very quickly take a look at one of these request handlers that is used in this process. Inside of my code editor, I'm going to open up the routes blogroutes.js file. So here's that file. If you scroll down just a little bit, you'll find a request handler that says app.get API/blogs. And inside of here, you'll find the actual Mongoose query that is used to retrieve a list of blogs to show to the user. So the point here is that every single time someone refreshes the page inside of our application, we always are issuing 2 separate requests to our Mongo database. Now, normally, that's not a very big deal. It's not a big deal to make 1 or 2 requests to Mongo anytime we refresh the page. However, I want to show you some considerations that go into that, because we could very easily get into a circumstance where making those repetitive queries every time the page is refreshed does turn into a big issue. All right, so let's look at a diagram here. All right, so I want to tell you a little bit about what goes on behind the scenes anytime Mongoose makes a query over to our Mongo database. Whenever we execute a Mongoose query, and that's like the line of code we were just looking at, right? This one right here. So whenever this is executed right here, that eventually sends a query to our running MongoDB database. MongoDB has something internally called an index. An index are matched up with an individual collection. And you'll recall that a collection is like a collection of individual records. So inside of our database right now, we have one collection of blogs and one collection of users. So let's imagine what happens when that query to retrieve a list of blogs that belong to a given user come in. The query arrives at MongoDB. The query is then sent to something called an index. This index right here is an efficient data structure for looking up sets of records inside of that collection. Indices are efficient because they allow us to not have to look at every single record inside the collection to figure out which one we're trying to find. Instead, the index might allow us to kind of directly beeline the record that we're looking for. So like rather than having to look at this record and see if it matches the query, and this one, 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 the index allows us to go directly to the record that we care about right here. Indices like this are what make MongoDB very quick. So whenever we have an index that is working properly, these lookups of records occur very quickly, and we don't really have to worry about any issues around performance. However, there's something to be aware of here. Whenever an index is created for a Mongo collection, an index targets an individual property that exists on these records. Now, to be clear, indices have a lot of flexibility about them, and we can tailor them to look at multiple fields together or to consider different properties. But in general, for the sake of discussion, let's just assume right now that every single collection we have only has an index for the ID property of a record. So let's then consider our blog post as we are saving them into our collection. Every blog post that we create has 3 different properties tied to it. It has an ID, a title, and some content. So because we have this index over here for specifically the ID property, that means that if we ever ask Mongo to give us a blog with a particular ID, this index can very easily go and find the correct blog post. So like maybe that one, or maybe this one over here. So anytime we ask for a blog post with a particular ID, that operation is very, very quick to execute. Now here's where things get a little bit more interesting. What happens if we issued a query where we asked for a blog post with a very specific title? So in this case, maybe we don't care so much about the ID of a post, and instead we want to find a blog post with a title. Well, if an index for the title property does not exist, then we don't enjoy any fast lookup of data inside of our collection. This index right here is only relevant for looking up IDs on records, and it's not used for any other property. So if we asked for a blog post with a specific title, Mongo would have to fall back to its default behavior, where it first looked at this blog, it would look at that title property and would say, okay, does this match the query? No? Okay, I'm going to go on to the next one. Does this one match? No? Okay, next one, next one, next one, next one. That process is what we refer to as a full collection scan. A collection scan means that we have to look at every single record inside of a given collection, which is an extremely expensive operation, relatively, of course, relatively extremely expensive. So the takeaway here overall is that sometimes when we make a query over to Mongo, if we have an index ready that satisfies the query, that query will be executed very quickly. However, you and I can very easily write queries that don't match up with an index or don't have an index available. So in those situations, we would very easily run into big performance concerns around our application. Now there's 2 ways to solve this performance concern. The first way, and this might seem like the really easy way, is to add in an index for that given field. So we can have multiple indices for a given collection. We could have one index for the ID property of these blog posts, and we could have another one for the title property as well. So that would allow us to look up blog posts with a very specific title very quickly and very easily. That might seem like a really obvious thing to do. However, whenever we add indices to a collection, that has an impact on our ability to write to that collection performantly. In other words, for every additional collection that we add, every additional index that we add to a collection, it takes longer to write records into that collection. In addition, anytime we add in more indices, that consumes more disk space and more memory as well. Finally, we might be making queries inside of an application where we can't really figure out ahead of time what indices we need for it. So maybe we start making blog post records that have like 30 or 40 different properties tied to them. And we might have to always be looking for different combinations of these properties. And we can't really figure out ahead of time what indices we would need for that. So in all those situations, this whole idea of using indices to solve these performance problems kind of go out the window, and we have to figure out some different solution. Okay, so in this section, we laid out some of the big performance concerns when looking up data inside of MongoDB. We spoke about how by default, we usually get these indices that help speed up queries. However, sometimes these indices are not working in our favor, and the query might occur much more slowly than how we expect. So let's continue in the next section. We're going to talk about how we're going to solve this issue using caching inside of our application, and then we'll start working on implementing caching inside of our project. So I'll see you in just a minute. In the last section, we spoke about some performance concerns that we might have with MongoDB. One possible solution to this is going to be setting up something called a cache server. In this section, we're going to talk about what a caching layer is when we wrap a MongoDB instance with it, and then we'll start working on implementing that inside of our application. So let's first talk about what a caching layer is. We'll first do a quick review of how our application is set up right now. So this is our application as it currently stands. On the left-hand side, we've got our React application running in the browser. That communicates with Express, that communicates with Mongoose, and at some point in time, Mongoose is going to attempt to reach out to MongoDB, issue a query, get a response. Mongoose is going to take the response, give it to Express, and Express will send that back to the React application. So that's what's happening right now, and I think that's a pattern that we understand pretty well. So we're now going to look at a very similar diagram to this right here, but it's going to add in one additional piece. And this additional piece is the caching server. So we're going to see what effect this caching server has on our setup. Okay, so here we go. So still the same thing on the left-hand side, but now in between Mongoose and MongoDB, we have this extra thing here called a cache server. So here's what's going to happen with the cache server. Anytime Mongoose issues a query, it's going to first go over to this cache server. The cache server is going to check to see if that exact query has ever been issued before. If it hasn't, then the cache server will take the query, it's going to send it over to MongoDB, and Mongo is going to execute the query. We then take the result of that query, it then goes back to the cache server. The cache server is then going to store the result of that query on itself. It's going to say, okay, anytime I execute that query, I get this response. And so it's going to maintain a record between queries that are issued and responses that come back from those queries. The cache server will then take that response and send it back over to Mongoose. Mongoose will give that data to Express, and it eventually ends up inside of our application. Now, any time that same exact query is issued again, Mongoose is going to send the same query over to the cache server, but this time, if the cache server sees that query has already been issued once before, it's not going to send the query on to MongoDB. Instead, it's going to take the response to that query that it got the last time and immediately send it back over to Mongoose. So there's no indices here, no full table scan, nothing. We're doing a simple lookup to say, has this query been executed? Yes? Okay, take the result and send it back over immediately, and don't send anything to Mongo. So that's the overall idea. Now, to make sure that the theory behind this is like crystal clear, I want to walk through the same process one more time, but with a more detailed and in-depth diagram. And we're going to see some of this occur like in this diagram. All right, so this one right here. Okay, so this is a very similar diagram, but I've blown up three portions. On the left-hand side, we've got the Mongoose server, the cache server, and MongoDB. So on the cache server, we can imagine that there might be some like data store inside there. It might be a key value data store where all the keys are some type of query that has already been issued before, and the value might be the result of that query. So in this case, we're saying that maybe we are looking up a bunch of blog posts by their ID. So maybe the keys here are the IDs of the records that we've already looked up before. So let's now imagine that Mongoose issues a new query where it tries to find a blog post with an ID of 123. this query is going to flow into the cache server. The cache server is going to check to see if it has a result for any query that was looking for an ID of 123. And in this case, nope, definitely does not exist. So this query is taken and sent on to the MongoDB instance. MongoDB will execute this query, get some response, and send it back. So we can kind of imagine that maybe the result of that query is a blog post like this right here. Something that has a title of my and content of blog. So this result is sent back over to the cache server. The cache server then takes that result and immediately sends it back to Mongoose. So that immediately gets sent back over, so we get as fast a response as possible. Immediately, like right after that though, or like kind of at the same time, the cache server will also take the query that was issued, which was to look for a blog post with an ID of 123. It's going to add that onto its collection of queries that have been issued. And then it's going to take the result of that query and store it right up against that query. So now we can kind of imagine that at some point in the future, we issued this same query again. So we're still trying to look for a blog post with an ID of 123. That would come to this cache server. The cache server would look at all the keys that it has. It would say, oh, I've already found a blog post with an ID of 123. So it would not reach out to Mongo at all. And instead, it would just take the result of that query and send it directly back over to Mongoose. So notice that this is like kind of a key value pair lookup here. We're not doing any type of like complex query logic. We're not using any indices, nothing like that. It's as fast as possible. It's a simple key value lookup. That's what we're doing here. Okay, so that's an overview of how this cache server is going to work. So you probably have a couple of questions here. You might be thinking like, well, what, we're only going to store IDs or lookups that use an ID? Well, no, we're going to write some code that's really fancy and will cache any type of query that Mongoose tries to issue. The other thing that I want you to be aware of, and you might already be thinking about, is, well, are we going to always cache all this data like forever? How do we ever update any records? And my answer to that as well is, don't worry, we're going to figure out a solution for that as well. So we need to think about how we're going to eventually kind of like expire data that is stored on this cache server. Because we don't want to always be storing data in the cache and always reading from the cache. Remember, one thing that's really important here, and I'm going to repeat this many times, the cache server is not used for any write actions. This caching layer is only used for reading data. So if we ever write data, writing is going to always go over to the MongoDB instance. And we need to make sure that anytime we write some amount of data, we clear any data stored on the cache server that is related to the record that we just wrote or updated. So just some things to be aware of. And I really just meant, if that doesn't make any sense, that's totally fine. I just mentioned those things to let you know that yes, we're going to cover those topics. That's the only reason I mention it. Okay, so I think we've got a better idea of how this caching mechanism works. So let's take a pause right now. We're going to come back to the next video and we're going to start to implement this cache server. So I'll see you in just a minute. In the last section, we got a better idea of how caching works in general. We're now going to dive into this cache server and learn a little bit more about how it's actually going to be set up and used inside of our application. Once we learn a little bit more about the caching server, we'll install some software that's going to serve as the caching server for us. So let's get to it. So our caching server is going to be an instance of something called Redis. Redis is an in-memory data store. You can think of it as essentially a tiny database that runs in the memory of your machine and allows you to read and write data very, very quickly. Redis is a data store that operates only in memory, and so that means that once it gets turned off or restarted or anything like that, all the data that sits inside of there is instantly deleted and wiped. So in practice, we only use Redis for data that we feel kind of okay having suddenly disappear into thin air. Because who knows, maybe we lose power or our machine gets restarted, you never know, and we lose all the data that's stored in there. Now Redis is very fast for reading and writing data. So all these qualities come together to make it a fantastic decision for handling something like a caching layer, where we want to make sure that it's very quick for reading data. To interact with this Redis server that we're going to be running on our local machines, we're going to use a library called node.js. Now, in fact, the library is only called Redis. This is the node implementation of the library. So I'm going to call it node.js throughout this course, just to make sure that it's really clear when I'm talking about the library that we're going to use to interact with it and the actual Redis server itself. So node.js is a JavaScript library that allows us to interact with the server. The server itself is called Redis. If you want to read more about the Redis library, so this is the node Redis library, just to be clear, you could go to npm and search for the Redis package. And once here, you can read a little bit about how it works. One thing I want you to be aware of, and I want to mention this right away, because this is something that I find a lot of people kind of find a little bit, I don't know, surprising, I suppose. This Redis library right here doesn't actually give any documentation on commands to manipulate the Redis data store. It only gives you generic commands on how to connect to it and manage the instance, but it doesn't actually tell you how to work with any data stored inside there. The authors behind this package decided that they don't really want to be responsible for writing that documentation. So essentially, they just take any commands that are supposed to manipulate the Redis instance and forward it onto the Redis server. So it's really up to us to use not only the documentation behind this package, but also the documentation for the Redis server itself to figure out how to interact with it. Long story short, the documentation here is not the best. That's kind of what I'm saying. Anyways, let's take a pause right now. We're going to come back in the next video, and we're going to install Redis on our local machine. The installation process is different depending on whether you are on Mac OS X or on Windows. So in the next two videos, find your respective operating system and watch that particular video to install Redis locally. All right, quick break, and we'll take care of that installation in just a minute. In the last section, we spoke about how we would be using the in-memory data store called Redis to handle caching inside of our application. In this video, we're going to install Redis on Mac OS X. So if you're using Windows, pause the video right now and continue on to the next section, where we're going to walk through the installation for a Windows machine. Otherwise, if you're still here and you're running Mac OS X, let's do the installation. So to install Redis, we're going to use the Brew Package Manager. We're going to first walk through the process of installing Brew, just in case you've never ran it before. In a new browser tab, I'm going to navigate to brew.sh, like so. I'll then find this Install Homebrew section right on the screen. I'm going to find the script right there and copy the entire thing. I'll then change on over to my terminal. So here I am. Now before we run that installation script, let's check to see if you already have Homebrew installed. So before you run the installation script, run the command which-brew, like so. So you'll notice that I got a path appearing right here. I see a path because I already have Homebrew installed. If you do not have Brew installed, then you will instead see a message that says something like command brew not found or something like that. You'll see some type of error message. So if you see an error message, then I want you to paste that script in there and run that command. Pause the video right now if that's the case. So if you're going to do the installation, then just pause right now and let the installation run. Okay, so if you're here still, we're going to go through and use Brew to now install Redis. So to use Brew to install Redis, all we have to do is run the command brew install Redis, like so. So run that, pause the video, it's going to take a minute or two, and then when you come back, we're going to run one or two other commands to configure Redis. Okay, so let's now run those commands. Obviously, I'm kind of assuming here you're pausing the video as you do the installation. All right, so you should see a message like this appear once you have completed the Redis installation. Now, the one thing we want to do here is to look at this little message down here. It says we can run that command, brew services start Redis, to automatically start Redis up right now and always restart it anytime that we restart our machine. And that's definitely what we want to do. So I'm going to run the command brew services start Redis, like so. And you'll notice that I get a message here that says, well, it's already started because I was running it. You might see a similar message, and that's totally fine as well. So that's pretty much it. That's all we have to do to install Redis. The last thing that we're going to do is just to confirm that it is in fact running and working on our local machine. So to do so, we can run a command Redis, let's do it up at the top here, Redis-CLI ping, like so. And you should see a message come back that says Pong. So that's pretty much it. That's all it takes to get Redis installed and running locally. So let's pause here. We'll continue in the next video and start to use Redis to implement our caching solution inside of our app. Now that we've got Redis installed locally, we're going to play around with it a little bit to understand how it stores data. Once we have a better idea of how it works, we can then use it to implement caching inside of our application. Let's first start off by looking to see exactly how data is stored inside of Redis. So we're going to look at a diagram really quick. All right, right in the center of this diagram is our Redis instance. Redis is a key value store. So you can think of it as storing data very similarly to how a JavaScript object stores values. We have keys, and those keys reference different values. We're going to use the node Redis library to eventually manipulate by setting and getting the values that are stored inside of Redis itself. The most basic way to manipulate values inside of Redis is calling this set function. The first argument is a key that we want to set, and the second argument is a value. So if we called set with hi and there, we would end up with a key in Redis of hi and a value of there. Now to eventually retrieve values out of here, we can use the get function provided again by node Redis. The first argument to get is the key that we want to retrieve. Now notice that in this case, whenever we are trying to retrieve a value out of Redis, that is an asynchronous operation. So we have to pass in a callback function as a second argument. This callback function right here will eventually be called with the value that was stored at the key of hi inside of Redis. So in this case, if we called get and tried to get the value at hi, our callback function would eventually be called with a value of there, because that's value. Now I can talk about all this stuff all day, and it, may or may not be helpful. I think that would be a little bit nicer to actually write some code to interact with our Redis instance. I think we could learn a lot more if we took that type of approach. So I'm going to change back over to my terminal. I'm going to make sure I'm inside of my root project directory, and then I'm going to start up my node REPL by running the node command like so. We're going to directly require in the Redis library. We're then going to use that library to connect to our running Redis instance, and then we're going to try to manipulate some of the data stored in there. So let's first require in the node Redis library. I'm going to say const Redis is require Redis, like so. Again, I'm calling this library node Redis just so you know what I'm referring to, but technically it is called Redis. We then have to instruct this Redis library how to connect to our client instance. We can do so by defining first a Redis URL. So this is going to be the URL that our instance is running at. So I'm going to say const Redis URL. And by default, your connection URL for the copy of Redis that we just installed will be Redis://127.0.0.1 and then port 6379, like so. We can then use the Redis library to connect to the instance at this URL and store the result on a variable called client by writing redis.createClient, and then we'll pass in the URL that we want to connect to, which is Redis URL, like so. So that gives us back this client thing, and this client thing is how we actually interact with our Redis instance. So if I reference simply client and print out the value, you'll see this big object right here that has a bunch of different methods on it that allow us to manipulate that Redis instance. Let's try writing some of the code that I just showed you on this diagram right here to try to store and retrieve a very basic value. So back over at the terminal, I'll write client.set. I want to set a key of hi and a value of there. Now notice how it immediately returns to me true. That just means, okay, I got it. I'm going to try to set that value for you. It doesn't actually represent the value that is being stored or anything like that. It's just a status message that lets us know that the client is doing its thing. Then to retrieve this value, we can call client.get, ask for the key at high, and then pass in a callback function as well. So I'll write out client.get. I want to get the value that is stored at high, and then as a second argument, I'm going to pass in a callback function. The callback function takes error as the first argument. So if something goes wrong while retrieving this key, it will be assigned, or an error object will be assigned to this value right here, or this argument. And then the second argument is the actual value that we're trying to retrieve. So I'll take that and simply console log it. All right, let's try running this. So now when I run this get to get the value stored at high, I see a console log of there appear. Yep, pretty straightforward. That's pretty much it. Now, one thing I want you to be aware of, writing out these callbacks right here is kind of annoying. So one way that we can kind of print out values a lot more easily is to write out client.get high, and then instead of writing out a full callback function, we can pass in a reference to console.log. Now notice that we do not have a set of parens after console.log, because we're not trying to call it, we are providing the log function as a callback. So after we fetch this information, after we fetch the value stored at high, console.log will be called automatically with the arguments of error and value. So let's try running this and see what happens. So now we get null in there. The first value right here of null is that error value. Null means that nothing went wrong with that operation. And then the second value we see console logged is there, and that's our actual value. So again, there's really no difference here, just a little shortcut so we don't have to write out a full callback function like so. Okay, so we now got a reasonable idea of how to set and get very basic values inside of Redis. But this isn't quite enough for us to really implement a caching layer. So let's continue in the next section, and we're going to write a little bit more code to figure out how to work with Redis. In the last section, we got a better idea of how to set and retrieve basic values stored inside of Redis. We're now going to move on and take a look at a slightly more complicated data structure, one that's going to ultimately be very useful for our caching project that we're working on right now. Okay, so we're going to take a look at a diagram. It's going to be a little bit crazy, but we'll go through it step by step. So this next data structure that we're going to look at is a nested hash. You can think of this as being like a nested JavaScript object. So at the top level, we still have a set of keys. But this time around, their values are not simple strings. Instead, the value that corresponds to this key of Spanish right here is its own nested object, or nested hash as we refer to it. So there is another set of keys inside of here. The key of red points to the value of rojo, which is a Spanish word for red. Orange points to naranja, which is the Spanish word for orange. And blue points to azul, which is Spanish word for blue. We can have multiple hashes like this stacked up inside of one instance of Redis. So Spanish points to its own nested object, and German right here points to its own nested object as well. To set values inside of a nested hash like this, we use a slightly different function. So before, we saw the set function, but to manage nested keys like this, we use set. The H here stands, you guessed it, for hash. So we're trying to set a value in a hash. A hash is another term for essentially the objects that you are used to working with JavaScript. The syntax here has three different arguments. The first argument is the overall key, like the master key that is managing this entire object. So Spanish here would point to the Spanish key right here. Red is modifying the key inside of that hash, and then rojo would be setting the actual value. So the first two arguments here are kind of like lookups of a sort. And then the third argument is the actual value that we want to set inside of that nested hash. To retrieve values, we use a similar syntax as well. Let me zoom in here so you can see it nice and easily. Okay, so we got hget right here. Again, hash get. The first argument is Spanish. We are specifying that we want to retrieve the value stored at red. So that would be rojo. And then again, the third argument is a callback function. It gets called with a value that is stored at the key of red. So eventually this would console log the value rojo. All right, now this diagram might not be making the most sense to you. So I do want to put this in different terms or show you a slightly different representation that might make a lot more sense. So we're going to first take a look at a little code snippet right here that represents the data that we set in the last video. Remember, we were setting a simple key of hi and a simple value of there. So if we put that data structure in terms of like a JavaScript object, everything stored inside of Redis would have looked like this right here. A simple key of hi with a simple value of there. So let's take this same kind of format right here and apply it to this idea of nested hashes. So if we took this kind of like language translation thing right here and wrote it out as a JavaScript object, it would look a little like this. So this overall object represents the entire data set of everything we have stored inside of Redis. Then inside of there, we have one key of Spanish and another key of German. Those both point at their own nested hashes or objects, and they both have their own set of keys and values. So red is rojo, orange naranja, blue azul. And German has its own set of like red, orange, and blue as well. Okay, hopefully this right here makes a little bit more sense in understanding exactly how this data is structured inside of Redis. Let's now change over to our terminal, and we're going to write out a little bit of code just to get some experience with working with nested hashes and retrieving values out of them. So I'm going to go back over to my terminal. If you have closed your terminal, remember you can get a client back up by running the command node inside of our project directory, requiring in Redis, defining the Redis URL, and then declaring a new client by calling redis.createClient and passing in the Redis URL. So that gives us this client object right here that we can use to manipulate Redis. All right, so let's give this a shot. Down at the bottom, or I guess top now, because I'm going to clear out my log, I'll first set a new hash, and I'm going to try to set, let's say, how about German with red and rot, however you pronounce that in German. So let's try to set like this key and set a hash on it with red pointing to rot. So to do so, we would do client.hset. We would pass in the overall key space, which is German here. So this is like the overall master key. And then we're going to say that inside of German is going to be another object or a hash inside there. It should have, what do we say, red. So we're going to say red, and the value that corresponds to that would be rot, like so. And again, we get back true to say, cool, we did it, command executed. So now to retrieve a value out of here, we could write client.hget German red, and then again, I'm going to use that little trick with console log. So I'm going to write out console log, but I'm not going to put any parentheses after it. And so now you see that we have an error of null, and we retrieve the value rot, like so. Now, of course, we can add in as many properties as we wish to this German hash. So I could also add in, what is another one here? Blue with blah. So blue and blah, like so. And now we could, again, retrieve out blue from the nested hash at German. So client.hget German with blue. Oops, and I forgot the console log, my mistake. And there we go. So we retrieve a value out. Okay, so that's just another little data structure inside of Redis that's going to eventually end up being extremely useful for us. At this point, I think we've got a reasonable idea of how to store basic values inside of Redis and then later retrieve them out. So let's now take this idea of Redis and everything we've learned and figure out some way of caching data inside of Redis. So quick break, and I'll see you in just a minute. There's one last quick thing that I want to mention about Redis before we start to actually apply it to our project. One quick thing, I promise. So this is a little bit of a gotcha, but it's a pretty easy one to wrap your head around. Anytime that we try to store data inside of Redis so far, we've always been sticking in like strings only. So whenever we store data inside of Redis, we only have the option of storing numbers and letters. That's pretty much it. In other words, we cannot store a plain JavaScript object directly inside of Redis. Let's try it out right now, and I'll show you what I mean. If I write out client.set, and then I try to set, like, say, colors, and then pass in as a second argument. So this is going to be the value that I'm trying to store here. If I say like red is Rojo, like so. So if I run this code right here, I'm going to see an error message. And it's not quite an error message, it's more of a warning. But it says very clearly that the object that I just tried to store got converted into the form object, which is almost definitely not what I actually want to store inside of Redis. So if I were to now retrieve the value that I just stored right there, so client.get colors and console.log, you'll see that I just pulled out a value of object. Definitely not what I wanted. So to get around this, we usually will stringify or turn into JSON any JavaScript objects that we want to store inside of Redis. So let's see an example of that. I could say client.set colors, but this time I'm going to take that colors object of red and Rojo right here, and I'm going to say JSON.stringify, and then pass in red and Rojo, like so. Now I see absolutely no warning because I can safely store JSON. And if I were to get colors now, I would see red with Rojo, like so. Now notice this is still in JSON format, so I would have to parse it by using json.parse. Let's do a very quick example of that as well, just so you see the full story. So I'll do client.getColors. I'll pass in air with val, short for value, and then I'll do a console.log with a json.parse val, close off the console log, and close off the get call. So now, very plainly, I can see that I get back the object red with Rojo. So that's how we store more complex JavaScript values inside of Redis. We can't just store them raw. We have to first turn them into JSON, and then when we pull it back out, we have to make sure that we parse the value as well. Okay, so that was the last thing I wanted to cover. So now, for real, in the next video, we're going to start setting up caching inside of our project. So quick break, and I'll see you in just a minute. All right, without further ado, we're going to start setting up caching inside of our application. Now to really set this up correctly, we're going to take a very specific approach. We're going to first set up caching around one very specific route handler. As we go through that process, we're going to learn a couple lessons. So we're going to figure out what kind of works well and what doesn't work quite so well. And then once we learn those lessons, we'll then extend our caching strategy to everything inside of our application. So we're going to start small, learn a couple things, and then write a much more generic and general caching strategy that works for everything inside of our app. So let's first get started by taking a look at the query that we're going to cache inside of our app. I'm going to flip back over to my code editor. I'm going to find the routes directory and then open up the blogroutes.js file. Inside of here, I'm going to scroll down just a little bit until I find the route handler for API/blogs right here. Inside of here, we are making one single query. So this is a query to find all of the different blog posts that are tied to the user who is making the current request inside of our application. So we find that list of blogs and then send them back to that user. So this is the call right here. This is the query that I want to try caching. Right now, every single time we call this route handler, we always reach out to MongoDB. And I don't want to do that anymore. I want to only have to reach out to MongoDB one time, and then after that, I want to figure out some way of serving up this data in a more clever fashion directly from Redis, just so we don't have to keep on hammering our Mongo server over and over again. Okay, so first thing to do is to figure out some data structure to use inside of Redis to somehow store this query along with its result. So let's take a look at a diagram where I'm going to propose one possible solution. I'm going to suggest that we first start off by trying to store simple key value pairs by using that set and get method that we looked at just a little bit ago. We're going to use a key of the query that we're making and then a value of the actual result of that query. Now, when I say the result of the query right here, understanding the value I think is a little bit more straightforward. The result of the query is the list of blogs. It's probably going to be like an array of objects where each object represents one individual blog post. Personally, I think that makes sense. However, the key here of query, that doesn't make so much sense. What does this mean? What am I saying that I'm going to store the query here? Like, what is the query per se? So we're going to spend a little bit of time to think about exactly what we can use as a key to somehow like cache data inside of here. So here's the overall rule that I want you to always follow when you think about what to use as the key for caching some data. We want to pick query keys, like these keys that get inserted in here, that are consistent but unique between query executions. In other words, if I have two completely different users who make a request to this route right here, they would definitely expect to get back two different lists of blog posts, right? So I want to make sure that those two users have unique but consistent keys to store data inside of our caching mechanism. Like user A should not somehow sometimes get the data that was stored for user B. And likewise, user A should always get their data no matter how many times they end up calling this route handler right here. So to somehow think of a key that is consistent and unique between executions, we need to look at the query itself that we're making and try to identify some value inside of it that is consistent and unique. Okay, so let's look at our code editor again. And we're going to look at this query very carefully. So when you look at this, you'll notice that there's really only two variables inside of here that kind of customize how this query behaves. You might only see one, but in fact there really are two. So the first one that's kind of obvious that customizes how this query works is rec.user.id. This is the ID of the user who is trying to get a list of their blog posts. This variable right here is always going to be consistent between requests to this handler. Like for each user who calls this, they're always going to have the same ID. And it's also going to be, wait, did I say consistent? Unique. That's the second one. Unique. It's always going to be unique. So every single user who eventually gets this query ran, they're always going to have a unique user ID. So rec.user.id right here is both consistent and unique. The other variable that's kind of floating inside this query right here that's a little bit harder to find is actually the collection that we're making the query over. So blog.find right here, we are saying specifically, look in the blog collection and try to find all the blog posts with a property of _user equal to this right here. So this really is a second variable inside the query. So if we were making, say, two separate queries inside of here, let's say we also had a collection of like tweets, like so, we could not only use rec.user.id as our caching variable or our caching key, because the same key or the same value is used over these two different queries. And if we only recorded this right here, we would be mixing up our collection of blogs with our collection of tweets. But fortunately, that's not the case this time around. We're only dealing with blogs right now, so we can simply use the user's ID as a caching key. Now I know this still probably seems a little bit confusing, but trust me, as soon as we start to implement a lot of this blogs or this caching strategy stuff, this key stuff will be a little bit more obvious over time. All right, now one last thing, I just want to show you a quick diagram here to really hammer in the picture here. So we are making a GET request to API/blogs. We are writing a query right here. This is our query. And we're trying to say in the blogs collection, find the blogs with user this right here. So again, the two variables that are floating around here is the fact that we're looking in blogs and the fact that we're looking in rec.userid. But for just this route handler right here, and remember, we're only trying to implement caching for exactly this one route handler right now, blogs is not really a variable that's going to change between requests to this thing. We're always looking in blogs. So we don't really need to somehow encode that into our key. We only need to worry about rec.userid. So in summary, if we consider what our data structure inside Redis eventually is going to look like, it's going to look a little something like this. We're going to have a set of keys that are user IDs. So this would be like user ID 123, 343, 952. And then the values are the list of blogs that that user has created. Okay, so this is going to be our first approach at implementing caching. This is going to be the first data structure that we try to use. Now this is, we're going to run into an issue or two, but that's part of the learning process. I just want to mention that very quickly. All right, so let's pause right here. We're going to come back in the next video and we're going to try to set up some caching strategy to encapsulate like using the user ID as a key, and the list of blogs as the values. So quick break, and I'll see you in just a minute. In this section, we're going to finally write the code out that's going to attempt to cache the list of blogs that are associated with a given user. So inside of my API/blogs route handler right here, we're going to first write out a little bit of code to create and initialize a new Redis client. We already wrote this code out inside of the node REPL a little bit ago, so it's going to look pretty familiar for the most part. Now, one other thing I want to mention right now is that for this first approach of caching these blogs, we're going to write all of the logic related to Redis and caching directly into this request handler. And we're doing that just so that we can easily clean up ourselves after we get some working implementation. So we are going to generalize all this caching logic very shortly, but first we're just going to test it out on this one handler. Okay, so that's why we're going to write all the code for this directly inside of here. So let's first get started by writing out some logic to require in the Redis library and then create a new Redis client out of it. So at the top of the request handler, I'm going to first require in Redis. I'll then define my Redis URL, which again is redis://127001 and port 6379 by default. We'll then create a new client that makes use of this Redis URL. So I'll say const client is redis.create client and pass in Redis URL. Okay, so as a reminder, let's walk over the logic that we really want to execute here, okay? So let's find a slide back here, where to go. This one's good. Okay, so remember, the entire idea here is that before we actually reach out to MongoDB, we want to first check to see if we have any cache data available for this particular query that we're trying to make on our cache server. If it does exist, we'll immediately respond to it and send that out to our React application. Other words, we want to reach out to MongoDB, issue the query, and then eventually send that back to Express and update our cache server with the result of the query as well. So that's the general idea here. Let's write out a couple of comments just to guide ourselves with this logic. So I first want to see, do we have any cached data in Redis related to this query? And we'll say, if yes, then respond to the request right away and return. So if we do have the result of this cache query available, we want to immediately send that back through the response and return from this handler. We don't want to do a darn thing else. Otherwise, if no, we need to respond to request and update our cache to store the data. Okay, so that's the general idea here. So let's now write in some code to satisfy these three comments. So at the very top, we're going to first check to see if we have any data already stored inside of Redis that matches this particular query we're trying to make. To do so, I'm going to write out const cached blogs equals client.get. And then remember, the thing that we're using as our key here is the user's ID. So every user has their own little pool of blog posts. So the ID alone serves as a unique and consistent key across requests to this handler. The user's ID is available on rec, remember that's a request, user.id. This is that user's ID right here. So I'm going to say client.get rec.user.id, like so. So that's step one. Now there's just one little issue here that we've already ran into without really realizing it. I took the result of client.get and tried to assign it to cached blogs. But as we saw just a moment ago in our terminal or in the REPL, whenever we call client.get right here, it does not instantly resolve with the result of the get operation. Instead, we have to make use of a callback function to get access to that thing. Now, I don't know about you, but there's no way that I want to try to write out all this complicated logic right here with the use of callbacks. Honestly, callbacks are kind of like a dying feature of Node, and we really try to avoid them as much as possible. Unfortunately, the Redis library that we're making use of here does not have native support for returning promises. But we can use a little bit of a trick Okay, so I'm going to show you a little trick here to modify the way that this client.get function works to make it behave a little bit more like how we want it to work, which is to return a promise instead of using this callback. So I'm going to delete this callback right here. And then right after we make this client thing, I'm going to require in another module. So I'm going to say const util equals require util, like so. This is a standard library that is included in the node runtime, and it has a bunch of, as you might guess, utility functions that we can use. One of the utility functions that is tied to this util module is a function called Promisify. Let me write that out because that's a tough word. Promisify. So this is a function. We can pass it another function like client.get, and it will return a new function that takes this thing's callback like nasty behavior and instead wraps it with some fancy logic that makes it instead return a promise, which is exactly what we want to do. So this Promisify thing right here takes any function whatsoever that accepts a callback as the last argument, like this one does, and it makes it instead return a promise. And that's the exact behavior we want. Okay, so let's write a little bit of code to Promisify the client.get function right here. Okay, so we're going to write this out. It's going to look a little strange, but just bear with me. I'm going to say client.get equals util.promisify client.get. And notice how I'm not putting a set of parentheses after the .get right here. So we're passing a reference to the .get function to util.promisify. This takes that function, it wraps it all up with some fancy logic so that instead of making use of a callback, it instead returns a promise. So util.promisify right here, it returns a new function that has been promisified. So we take that new function and we overwrite the existing one on client.get right here. So that's the entire idea. Okay, so we're going to overwrite the existing function with this new fancy one that instead returns a promise. So now we do not have to use a callback here, which is exactly what we want. Okay, so now the very last thing, down here at client.get, so now instead of using a callback, because this thing returns a promise, we can now use the async await syntax with it, like so. So we put await, that will await for this promise right here to be resolved, and then whatever it resolves with will be assigned to cached blogs, which is hopefully our list of cached blogs. So that's pretty much it, at least for this part right here. Let's take a break right now because we did cover a lot in this section. We're going to come back in the next video and we're going to start to implement the rest of this request handler to handle caching inside of our app. So I'll see you in just a minute. In the last section, we wrote out some logic to promisify our client.get function. We then use client.get to check our Redis cache to see if we've ever fetched any blogs related to this particular user before. We then assign that to cache blogs, and now we're going to move on to the next step of our logic right here. So we're going to say if we have stored a list of blogs, like if cache blogs contains a list of blogs, then we're going to try to respond to our request right away and return from this handler. So to do so, we're going to write out if cache blogs, like so. So if nothing exists at this key, if there's no value there, cache blogs will be null or undefined. Those are falsy values. So if we just write out a simple if statement right here and cache blogs is not defined, then we're just going to skip right over this block entirely. So then inside of here, assuming that we do have a list of blogs, we'll write out our logic to immediately send back a response and return from the request handler. So for that, we'll write out return res.send cached blogs, like so. So now we'll handle the other case, the case in which we do not have any cache blogs. So in this case, we do have to issue our query over to Mongo. So that's this query right here. So we're going to let this thing run. We'll then take this result, we'll send it back to the user, and then we'll update our cache with this list of blogs. Now notice that we've got this kind of like if yes, if no statement right here. We do not have to put on an else here. We don't have to put on an else because inside this if statement, we have a return. So if we go into the if statement, we are going to return, and nothing else inside this handler is going to run. So we don't need another like else statement here or anything like that. Okay, so right here, we are going to let the query run. We get our list of blogs, we assign it to the variable blogs, we send the response back to the user, and then the last thing we have to do is update our cache and store the list of blogs that we just found. So I'm going to say client.set. We've used the set function a couple times now over inside of our REPL. Remember, the first argument is going to be the key that we want to define, and the second value will be the actual value that we're trying to assign to it. So client.set, and I'll say rec.user.id. So that's the key that we want to define. And then the second argument is going to be our list of blogs. So I'll pass in the list of blogs we just found. Now, before we try to test this out, one big thing. Remember what I just told you 2 videos ago. Whenever we store objects inside of Redis, we have to stringify them into JSON ahead of time. So blogs right here is an array of objects where every object represents one individual blog post. So we have to make sure that before we pass this thing in, we convert it to JSON. And we also have to remember that this thing that we're pulling out of Redis right here, this is this is JSONified as well. So we have to turn this back into a regular JavaScript array full of objects as well. So let's not forget that step. Okay, so down here at client.set, I'm going to make sure that I stringify this before I pass it into Redis. And then back up here, after we pull this thing out, I'm going to make sure that I parse this from its string form as well. And I think we can just parse it right before we actually try to send it back to the user. So I'll do json.parse, like so. Okay, so that's pretty much it. That's all the logic we have for this request handler, and we're now just about ready to test this out. Before we do, I want to add in one little line of code that's going to help us really understand what's happening. So inside this if statement, I'm going to add on a console.log. I'm going to say serving from cache. So if we see this console log, that means that we are not touching MongoDB at all. And then down here, I'm going to add on another console log. I'm going to say serving from MongoDB. So now we'll have a really good idea of where our data is coming from. All right, I'm going to flip on over to my terminal. I'm going to make sure my server is still running. Remember, you can start your server up by running npm run dev. Once it's running, I'll then flip back over to my browser. I'm going to open up my blog application, and I'm going to refresh the page one time. Now, if you're not at localhost 3000/blogs, you just have to get to that URL. So remember, localhost 3000/blogs. That's when the API/blogs route gets fired from the React client. So I'm going to refresh this, and I still get my blog appearing on the screen. Now let's check our terminal and see which of the 2 console logs appeared. Okay, this is kind of a letdown. It says serving from cache. There's a very good reason for that. It's because I actually tested this out before this video and I forgot to clear my Redis instance. So I'll tell you what, let's, as a neat like kind of side thing that you should probably know anyways, I'm going to show you how to like delete all the data that runs inside of Redis. So little quick side topic here that I was not quite expecting, but nonetheless, here we are. So we can pop open our node REPL really quick. And if we set up our Redis client again, like so, we can call client.flushAll, I believe it is, like so. So client.flushAll, notice how it's lowercase a right here. That will just wipe all the data that is currently stored inside of Redis. So that will give us a little bit more of a clean slate to test this again. Let's just pretend that didn't happen to me. Okay, so I'm going to go refresh again. Now if I go back over to my terminal, I see serving from MongoDB. Definitely what I expected. Definitely what I expected. But now here's the cool thing. Here's the real test. Now, if I go back over to the application again and refresh the page a second time, let's see what happens now. So I'm going to refresh again. I'm going to open up the terminal, and now you'll see serving from cache. So this first call to MongoDB right here, that went to Mongo, it got our data, it returned it, it then stored it inside of Redis. And now the second time we refresh the page and make a second request to that handler, our data is now inside of Redis, and so we are serving this data from our cache. So if I refresh a couple times now, So I can refresh, and maybe, what the heck, one more time. And now go back over to my terminal. You'll see that we are always serving this data from our cache. So definitely working the way we expect. Now, a couple of quick caveats I want to throw out here, or maybe just one for right now. You might notice that it's really taking a long time for these requests right here to resolve. You might be thinking, well, Steven, shouldn't this have like really sped things up? Just one thing to keep in mind, we are only starting up this Redis client when a request comes into our request handler. So when a request comes in, at that time, we are requiring in Redis, we are trying to connect over to Redis, and we're doing all this extra work right here. So right now, things might seem a little bit slow, mostly because we are doing all this extra work the instant any request comes in. Obviously, that is not at all ideal, and we absolutely will refactor this to a much more slick and reusable fashion. So with that in mind, let's take a break right now. We're going to come back in the next video, and I'm going to show you a couple things that are kind of missing or not quite working as we would expect with our current caching setup. So I'll see you in just a minute. In the last section, we got our Redis setup all working, and we're definitely serving data from cache now. However, there's definitely a couple of really big issues that we have with our current setup. So I'm going to point out like probably 2 or 3 things that definitely need to change in our current setup. After we understand these problems, we'll then start to refactor all this stuff into a much more maintainable and really cool looking fashion. Okay, so I'm going to first change on over to my browser again. And now I'm going to go through the process of creating a brand new blog post. Okay, I'm going to make a new blog post, a second one. So I'm going to first just copy my lorem ipsum text here really quick. I'm then going to create a new blog post by clicking on that red button down there that you saw just a second ago. I'll put in my second blog post as the title and my lorem ipsum text as the content. I'll click on next, I'll save it, and I think that's good. Okay, so I just created another blog post, and hey, as a user, I definitely would expect to now see that blog post in this list right here. So let me go ahead and refresh the page and see that second post appear. So I'm going to refresh, and hey, wait a minute. No matter how many times I refresh the page, I do not see that second blog post appear. Well, you know what? I think that's probably not that much of a surprise. Remember what we've said so far. We have said very clearly, anytime we try to make a query, we first check to see our cache and see if this query has already been resolved and stored inside of our cache. And that has definitely happened so far. We have said that for this particular user, go get their list of blog posts, store it inside of Redis, and that's it. We have implemented absolutely no logic whatsoever to ever somehow reach back out to Mongo and update that query. We're not trying to update it in any way, shape, or form, which is clearly not ideal. Now there's 2 other things I want to mention. That right there is a big problem, obviously, and we'll figure out how to fix that, but there's 2 other things I want to mention about our current setup. Okay, so the next thing I want to mention is the one that's kind of obvious. Looking at this request handler, we've got a tremendous amount of logic inside of here, all dedicated to just caching our data, right? Like we got this if statement, we got these alternate res.send functions. This request handler went from being 2 lines of code to being like, I don't know, maybe about 20 lines, maybe 25 lines of code, something like that. So clearly our current setup for handling all this caching logic, even if it worked the way we expected, does not really fit well into our existing code base. Without a doubt, I do not want to eventually have a bunch of request handlers that have a bunch of logic to like try to look up the client key, the cache key, and then say, hey, do we have anything? Well, then return that. And then otherwise, do the query and store it inside of Mongo or Redis and all this stuff. So right now we've got so much like extra baggage or extra logic inside of this one request handler. And there's no way I would ever consider it acceptable to copy paste all that code into every handler inside of my project. So without a doubt, we need to think of a way that dramatically makes this code, all this caching stuff, far more reusable than it is right now. So that's the second big thing that I think we need to be aware of. Now the third thing that we need to kind of think about a little bit and try to figure out how to fix is that right now our caching key is based on our user ID, right? That's what we've been saying. We've been saying that every single time that someone makes a request, where is it right here? Every time someone makes a query, we're going to store the result inside of Redis where the key is the user's ID and then the value is a list of blog posts. So what would happen if we introduced a second resource into our application that we wanted to cache? Like, what would happen if we also had a list of tweets or like pictures or anything else? Would we still use only the user ID for that resource as well? Because then sometimes when we looked up a key, it might return a list of blogs, and then other times it might return a list of tweets or images or whatever else. So I think that above everything else, we also have to consider the fact that right now our caching setup is really only good for one singular resource, which is definitely also not very acceptable. So I think we've got a couple of problems cut out for us. We've got some code, or like the fact that none of our values inside of our cache expire. That's problem one. We have a bunch of code that is not at all reusable. That's number two. And number three, our caching keys right here are probably going to get clobbered all the time whenever we start introducing new resources into our application besides just blog posts. So that's three big things we have to fix. So let's take a pause right here. We're going to continue in the next video, and we're going to start to refactor our setup, all this caching logic, into a much more reusable, correct, basically just better. Let's leave it at that. It's going to be better. So let's pause here, take care of that in the next video. In the last section, I laid out a couple big issues with our current caching setup. In this video, we're going to talk about those issues and propose a couple of solutions to each of them. All right, so let's take a look at a diagram. So I've listed out all of our problems on the left, and I've got a couple possible solutions on the right. So the first big problem we ran into was that our caching code, not at all reusable. Without a doubt, I think you would agree. Everything we have is inside of that one request handler. So as a possible solution, and this is going to be kind of crazy, but it's going to work out really well, trust me, I think that we need to figure out some way to hook in to how Mongoose makes a query and executes it against MongoDB. That might sound crazy, but bear with me for a second. Just think about it. Our entire caching strategy is based on the idea of somehow stopping Mongoose from making a query over to Mongo. And it also is based upon the idea of somehow intercepting the value that comes back from Mongo as well, so we can store it inside of our cache. So this entire idea of caching is incredibly tightly coupled with Mongoose and when a query is executed. Now, to really understand this step right here and what I'm going to suggest, we have to understand a little bit more about how queries inside of Mongoose works. So we're going to take a quick aside very quickly, maybe not too quickly, but I'll do my best. And we're going to take a quick review of Mongoose and what queries are in Mongoose. All right, so I already pulled up the documentation for Mongoose right here. So I'm at mongoose.js.com, and I'm looking at the queries section. So inside of here, I'm going to scroll down a little bit, and I'm going to find something that talks about like customizing queries. You'll see it right down here. So this is working with an imaginary collection of person. They make a new query, and they tack on all these additional statements here. They then limit the number that come back, they sort it, they select particular fields, and then finally they execute that query. So I want to copy paste this over to my code editor really quick, and I want to point out a couple of very interesting things about what's going on with this code snippet right here, okay? So I'm going to copy this, and I'm going to put it over in my editor, and let me turn on JavaScript. And then just because I'm super crazy and I don't like the right aligned period, I'm going to move it over to the left-hand side. Much better. And we'll fix that one too. There we go. Okay. So one thing that is not super well known about Mongoose, because it's not something that you'd ever really cared to take advantage of, is the fact that whenever we reference a collection and then start saying like find and where and limit and sort, it creates what's called a query object. So I could, in theory, assign the result of all this stuff to this query variable right here. Now there's just one problem with what I've written out so far. Person.find, like all these modifiers, the where, the limit, the sort, the select, these all return new queries that have been further customized in some fashion. However, the last line of code right here, the .execute or .exec, is what takes this query and actually executes it and sends it off to MongoDB. So I want to take that line of code off for just 1 second, okay, and leave it just like this right here. So now at this point in time, this query object right here, it represents some pending query that might be issued over to Mongo at some point in the future. So it has not been issued yet, it has not been sent over, but very shortly we can execute this query and send it off to Mongo. Now, if you think about it for a second, that entire process right there of like formulating some query and getting really close to sending off to Mongo sounds like it's incredibly related to our timeline and our life cycle of our caching system. Remember, we've said so many times now, whenever we are about to make a query off to Mongo, we first want to check to see if this data has already been fetched in Redis. That's the key. So when we create this query, and we got this query right here, and then like the next line of code might be something like query.exec, like so. This part right here, like this little gap right here, check to see if this query has already been fetched in Redis. Okay, so between formulating the query and actually executing it is when we want to make that check right there. And this might sound like kind of weird stuff, but let's just keep going for a second. And I think you're gonna kind of like what eventually happens here. Okay, so next thing I want to do is I want to tell you a little bit more about this exec function right here, because this is not a very well-known function. As a matter of fact, if you look at all the code that already exists inside of our project, you're not going to see the word exec anywhere inside of it. But I just said 2 seconds ago, this is how we actually execute a query and send it off to Mongo. So there's actually 3 different ways, kind of like technically 2, but more or less 3, to trigger a query to be sent off to Mongo. This right here is one possible way to trigger a query. The full signature of this line right here is query.exec, and then it takes a callback that gets called with an array object and the result. And then we could say like, console log the result like so. So that's one possible way to execute a query. That line of code right there is pretty much identical. I'm going to mark this as being like same as writing out query.then result and then console logging the result. So this .then right here is, it's part of a promise, but whenever we call .then, it actually behind the scenes also calls .exec and causes the query to actually be executed. So you might have seen in the past some Mongoose code where they use a promise like this right here. That is the same thing as actually directly calling exec. And then the last way that we can actually execute this query, so same as, would be to use the async await syntax. Now async await technically is making use of the underlying promise here, but I'm going to list it out for completion's sake. So it'd be something like await query like so. And this right here is what we are doing inside of our code base. So the point that I'm trying to make right now, the big point that I'm trying to make is that everywhere inside of our code base, you and I are executing queries by writing this line of code, right? Writing that line of code is more or less the same as running this line of code. This exec function right here is operating on a query that has already been formulated. Like we've already customized this query to a tremendous degree. And before exec is called, we have this like query object thing that we could read some details in about. So again, this is going to be like kind of hard to wrap your head around right now. This is like the first taste I'm going to give you, and we're going to like really dig into this very deep. So this is just the first taste I'm going to give you, but here is the suggestion I'm going to make for getting some really reusable code. Because remember, that's what we're talking about right now. Like how do we write some reusable caching code? So I'm going to suggest that we do something really crazy. I think that you and I should figure out some way of overriding the built-in exec function. I think you and I should figure out some way to overwrite this function right here for all queries that are created. And inside that function, we should write our logic to check to see if this query has already been executed. And if it has, return the result right away. Otherwise, issue the query as normal and then save that value in Redis. Okay, so let's put in a little bit of pseudocode here to like kind of imagine how this might work, and we'll bring everything full circle. So first off, we need to check to see if this query has already been executed. So we might write something like, client.get query key, and then we'll do that same check as before. If, let's assign this to like, result or something. So if result, return result. And then otherwise, run the original query function. So remember, the idea here is that we're going to overwrite, or excuse me, not the original query function, but the original exec function. So the original exec function is what actually kicks off the query to Mongo. So I'm suggesting that we overwrite that function here. So whenever we call this new version of exec that you and I are going to make, we're going to execute this logic. If this fails, we'll then run the original exec function that's going to actually, go make the request over to Mongo. We'll then take the result of that. We'll store it inside of Redis. So we'll do something like, redis.set or client.set query key, and we'll store our result in there. And then we'll finally return the result as the exec function normally would. So what I'm suggesting here is we hijack how Mongoose works out of the box. We overwrite the exec function to kind of like insert in or like nudge in our forced caching code. And then whenever we call or whenever we make a query, by default, we can have it just automatically be cached for us. And you and I will never have to write any extra code inside of these request handlers to worry about setting up all this custom caching logic. Okay? So again, I know this might be tough to wrap your head around right now, but as soon as we start writing the code, I think you're going to get a really good idea of what I'm going for with all this stuff. Okay? I think you're going to really think this is some cool stuff, because it is, trust me. Now, before we move on, we still have these two other issues that I want to address very quickly. So we just got kind of like a taste of how we're going to make this caching code super, super reusable. Now, the next thing I want to mention here is the fact that right now our cache values never expire. So Redis internally is designed to behave as a caching system. Like they know, the people who make Redis, they know it's used for caching. So they have a couple of built-in tools to aid in common operations that are involved with caching. One common thing that's included in Redis is the ability to automatically time out values that have been set. So in other words, after we cache a value, we can tell Redis to automatically expire that value after like 5 or 10 seconds or a day or 5 days or whatever we want. And so that's a very basic way that we can ensure that we do not forever cache every value inside of our application. We can say that once a value has been cached, we can keep it around for like, 15 minutes, and then eventually say, okay, that's enough, like let's dump it and refetch that value just to make sure it's the most up-to-date one. Now that timeout thing is really pretty straightforward, so I'm going to give you a very quick example of how it's done. So I'm over at my terminal again. I've got my node REPL. I created my Redis instance. Here's the URL, the client. I have deleted all the entries inside of Redis already, and I went ahead and set a new value. So you see right here, color is red. I then called client.get, and I tried to retrieve the value of color. And then I console logged the value. And I got back, as I would expect, red, without a doubt. So if I now tried to get out color one more time, I get back red again. Definitely what I expect. So now I'm going to try to update the value of color right here, but this time I'm going to add in an automatic expiration, okay? So I'm going to write in client.set, we're going to do color, we're going to do red, but now I'm going to add in 2 additional arguments. As a third argument, I'm going to add in the string EX with capital E, capital X, right, like so. EX, as you might imagine, stands for expire. So automatically expire this thing after some period of time. And then as a fourth argument, I'm going to pass in the number of seconds that I want this thing to expire after. So I'm going to say expire after 5 seconds. So as soon as I run this code and set this value, I can retrieve this value for the next 5 seconds, but after that, poof, it's just going to be gone. So let's try this out. So I'm going to run this line, and then I'm going to call get a couple times in a row. And we're going to see how long it takes for this value to expire. So there's the set. I'll now get, so there's red, 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 and null. So now you see for 5 seconds, I was able to still retrieve that value. And then after 5 seconds, it went to null because the value expired. So that's a very easy way that we can implement some very basic cache expiration, inside of our Redis system. Now that's definitely like a good place to start, but it does not really solve the issue that we saw just a moment ago when we were creating a new blog. Remember, when we created a blog, it did not appear in this list right here. And if I'm a user, if I make a blog, I expect it to instantly appear on the screen. Like I want to see it right away. Our users don't want to have to wait for some like cache expiration, right? If you set a cache expiration of 60 minutes, then who knows, they might have to wait 55 minutes to eventually see that blog post appear on the screen. And they're going to think your website is just broken, period. So even though this expiration, this automatic expiration thing is useful, we should probably also think about some other way to reset a lot of values in bulk inside of our Redis cache whenever some user does some specific thing, like let's say create a new blog post. So we're going to come back to that topic, that like second part right there, and we're going to think about some way to much more programmatically say like, hey, this entire block of cached values, someone created a new blog post, so all these values right here, they're just done. Just throw them away, toss them out the door. Okay, so that's cache values never expire. Now, I know this is a long video, but hey, let's just charge through because this is some pretty key stuff right here. Cache key stuff, that is. That's an awful joke. Anyways, cache keys won't work when we introduce other collections or query options. So as we saw just a moment ago, inside of our request handler of API/blogs right here, we are using a cache key. Where is it? Here it is down at the bottom. We're using a cache key of the user's ID. So as soon as we start to customize our query or the collection that it operates over in any way, shape, or form, this cache key right here is going to break down. So let me give you a good example of that. Let's say that we start to, so here's where we do that initial set right here with the cache key. So if we decide to instead cache also tweets on the user's ID as well, well, boom, we just broke everything. Another way we could very easily break all this is if we further customize the query beyond what has been added to it right now. So if I go down to where we are issuing the query, so here's the query right here. So right now the only variable in here is that ID. But what would happen if I also said like, find all the blog posts that has this user and have a title of like first blog? Well then when I tried to issue this query right here, I would still, assuming that my cache is populated or not populated, I have further customized this query and it's now different compared to how it was before. So my result set that's stored on this cache key would need to be updated, but I don't really have any good way of customizing that in any way, shape, or form. Only using the user ID as we are right now definitely is not going to work out in the long term. We definitely need some way to not only customize the cache key based on these query options that are passed in, but we also need to customize it based on the collection that we are trying to make the query over. So for example, if I had these exact same query options right here, or this exact same kind of like filtering criteria, but I was running it over tweets or something like that instead, well, then I clearly could not only use this option, these filtering criteria as my cache key. I would have to also somehow include some information about what collection this query is being issued over. So as a solution, and this is going to be a pretty straightforward one. Oh, I only put on here, figure out a more robust way. Well, that's not very clear. Well, I got a good solution. So let me show you something. I think this is going to be pretty clear. So I'm going to go back over to the code. Here we are. So this is the query that we were looking at just a second ago that comes from the Mongoose documentation. So you can see in here, we are looking at this person collection, and it is doing a massive amount of customization to this query. So if I ran a query that was like just those two lines right there, and then I ran a query that was all of this stuff, I would expect to get two dramatically different result sets. So I would want to store both of those query results on different keys inside of Redis. So I need to figure out some way of not only encapsulating like this collection name, but all these different options that are tagged on here as well. So to do so, we can run a function query get options, like so. So remember, we assigned this whole query right here to the variable query. So queries have a function on them called get options. This returns in one single object all of the different options that we have chained onto this query. So if we called get options on this thing right here, it would return to us something like find, I don't know, occupation host, and where probably like an array name.last is ghost, and so on. Basically, one object that represents all the different customizations that have been made to this query. As soon as we actually run this line of code, you'll get a much better idea of what I'm saying here. But basically, if we call query.options, we get one very unique string back that represents only this query alone. So I think that what we could do, and this might sound kind of crazy again, but if we turned this entire query option object into a string, so if we stringify, like JSON stringify this thing right here, we could use this big customized option object right here as the query key. Because this query right here, this like query string right here, this is both unique compared to any other query we might make, right? If we like change, if we subtract that out, that would then remove like maybe this block right here. So definitely as soon as we change the query, the key would change as well. So it's definitely unique. But if we always have the same options, like we always have where name.last equals ghost, then it would also be consistent. So if we take these options, turn them into a string, and use that as our key, that satisfies the requirements of being both unique and consistent across queries. Whew. Okay, I know this has been a super long video. I can't apologize enough, but I really just wanted to like jam everything into one video here. So I know that some of the stuff I'm talking about sounds like crazy talk. You know, I think the timeout stuff was pretty reasonable, but definitely this like hooking in stuff and the cache key stuff sounds pretty crazy. Again, this is an advanced course, so my goal was to give you like as challenging but doable as I possibly could. So we are gonna, I guarantee you, you're gonna learn all this stuff, okay? I know it sounds crazy right now, but I guarantee you, you're gonna get a really good idea of what's going on. So let's continue in the next video. We're gonna start to do a little bit deeper dive into Mongoose and figuring out how to satisfy each of these requirements right here. So it's gonna be a lot of fun. Let's continue in the next video and we'll get started. In the last section, we had a long discussion about how we're going to solve some big issues around our current caching setup. In this video, we're going to move on to writing a little bit of exploratory code to figure out exactly how we can first hook in to the exec function that is tied to every query that is issued by Mongoose. And we're also going to write some code to figure out how to generate a unique cache key that is based on the query that we're working with. The first thing we need to do here is understand some of the code inside of the Mongoose library itself. If we can understand how a query is actually created, we'll have a better idea of how we can actually hook in to the exec function itself and write and run our own custom caching code inside that. So I've taken the liberty of already opening up the Mongoose library on github.com. So this is the actual source code for the Mongoose library. We're going to take a look at the actual source code for queries that are created by Mongoose. And once we understand how that source code works, we'll have a better idea of how to hook in to that exec function. So inside this repository, I'm going to find the lib folder. This is where all the actual useful code inside of Mongoose sits. So I'm going to open up lib, and then inside of here, I'm going to find a file called query.js. Here it is right here. So as you might imagine, this has all the logic inside of Mongoose tied to writing, filtering, and issuing queries. Inside of here, I'm going to scroll down just a little bit. And as I scroll, unfortunately, this is kind of a laggy page for me, so it might take me just a second. All right, there we go. So around line 45 or so, you'll find a function called query. All of Mongoose is written using classical prototypal inheritance for setting up objects and classes inside the library. If you don't quite remember how prototypal inheritance works, remember it's basically how objects can inherit methods from other objects inside of JavaScript. So I've got a quick example to just give you a quick reminder of how this works. Okay, so we're looking at the function called query right now. That's what we refer to as a constructor function. Whenever we create a constructor function, we can use the new keyword on it, and that creates an instance of an object that is produced by that function. So if we say new query, that gives us back an instance of query. Now to add functions to that object that is created, we can assign them to the prototype property of the constructor function. So for example, if we want to make sure that every query that gets created has a function called find, we can assign it to query.prototype.find. Or for example, query.prototype.exec and prototype.limit. So then whenever we create a new query, they automatically get assigned that find, exec, and limit functions. So that's exactly how all the code inside of Mongoose is set up. It's using what we refer to as classical prototypal inheritance. All right, and so we can see a very good and simple example of that back inside of this query.js file. Here's our constructor function. This is what is called behind the scenes whenever you and I create a new query by saying something like, maybe for example, something like, well, here's a good example right here, blog.find1. So that's the same thing as directly calling new query, that query constructor function. Behind the scenes, that's what's actually getting called here. Okay, so now if we scroll down just a little bit, you'll see an example of where that prototype property comes into play to set up the inheritance stuff. So you can see right here, this is some very classic JavaScript code for setting up prototypal inheritance. And if you scroll down just a little bit more, you'll see where that prototype is used to assign a new function. It's like here's query.prototype2 constructor. And we can see an example of that if we say do a search on this page for .find as well. So query.prototype.find. Again, this is some kind of like more basic JavaScript stuff, and my goal right now is to just give you a better idea of how a query is created by Mongoose itself. Now the function that you and I actually care about is the exec function. That's the function that we want to somehow hook into or somehow override and add in our own custom caching logic. So on this page, I'm going to do a search for query.prototype.exec. And here we are around line 2934, so quite a large file. So this is the function that eventually gets called to actually run one of our queries. So you and I want to figure out some way to overwrite this function or add in some additional logic to it to make sure that we also check to see if a cache exists or an entry in our cache exists before sending this query off to MongoDB. Now the most important thing to recognize about this function is that it expects us to always return a promise. That's how we get some level of chaining from this thing. That's how we can actually wait for the query to be completed before trying to access the information that it actually retrieved. So eventually, no matter what we do, no matter whether we are actually running the real exec function or trying to access our cache or whatever, we need to make sure that we always return a promise. Okay? Okay, so I hope that part, at least is just a little bit clear where this function is defined. It's defined on query.prototype.exec. So you and I are now going to write a little bit of code that's going to try to hijack this function right here and try to run a little bit of custom logic whenever a query is issued. So I'm going to flip back over to my code editor. Now the first thing we have to do is figure out where to write this code. Where are we going to write some stuff to somehow monkey patch that library? Well, inside of our root project directory is a folder called services. The idea behind this services folder right here is to locate in one location any code that touches many different parts of our project. Right now, the services directory holds the passport.js file because that is holding all of our authentication logic, and authentication is used in many parts of our app. So I think that we're going to write all of our caching logic inside of a new file inside of services as well, because caching is a part of our application that's going to touch many different areas of our code base. So inside the services directory, I'm going to make a new file, and I'm going to call it cache.js, like so. Then inside of here, I'm going to require in the Mongoose library. So I'm going to say const mongoose equals require mongoose. All right, now this is the part where things are going to get just a little strange, okay? So now we're going to see why we just looked at that Mongoose source code. I want to get a reference to the existing default exec function that is defined on a Mongoose query. We're then going to overwrite that function and just figure out how we can manipulate or execute extra code whenever the query is executed. So I'm going to write const exec is mongoose.query query.prototype.exec. So this right here stores a reference to the original exec function, like the untouched copy of it, the copy that is supposed to be executed anytime a query is executed. And then immediately underneath that, you and I are going to write a little bit of extra code that tries to overwrite this function and add in some additional logic. So I'm going to say mongoose.query.prototype.exec. I'm going to use my function keyword here. Now notice we're using the function keyword and not an arrow function. That's because an arrow function tries to mess around with the value of this inside the function, and in this case we don't want to do that. This is a function that's being assigned to the prototype property. So inside this function, if we were to write out this, it should reference the query that is being produced. Long story short, we want to use a function keyword here and not an arrow function. Okay, so now inside of here, I want to write just a tiny bit of code that's going to somehow run before any query is executed by Mongoose. So I'm going to write out console.log, I'm about to run a query. And then right after that, we're going to run the original exec function. Okay, so we're going to run the original function just so you get a good example of how this thing works. So I'm going to say return exec.apply this and arguments, like so. So this right here is the code that we would run to execute the original untouched pristine copy of exec that you and I have not messed around with. We use the apply function so that we can pass in automatically any arguments that are passed into exec as well. All right, so let's now require this cache file into our project, and then we should be able to refresh our page and see this console log appear. And that's basically going to be our proof that we have the ability to hook into and execute some extra logic before any exec is called. All right, so back inside of my index.js file, I'm just going to require in that caching logic. So about right underneath our existing services passport call, we'll do services/cache, like so. And then I think I forgot to save the actual cache file, so I'm going to save that one as well. Okay, so now I'm going to flip on over to my terminal and just make sure my server is still running. Looks like it is. And now I'm going to go refresh my application inside the browser. So back over here, I'll refresh the page. I'll then flip on over to my terminal, and notice how now we see that console log of I'm about to run a query twice. So presumably that is some queries that are fetching the current user or who knows what inside of our application. But the point here is that we now have the ability to inject some extra logic that will be executed before a query is actually sent off to MongoDB, which means we can somehow intercept that query, check to see if the query has already been fetched, and if it has, return the data from Redis as opposed to actually sending the query off to Mongo. Okay, so I know this video has been a little bit crazy. You might have never actually monkey patched a library like this right here before, but this is a perfect example of how it's done. So let's pause right here. We're going to come back to the next video, and we're going to start to add in some more logic to kind of divine information about the query that is being issued. In the last section, we finally saw how we can overwrite an existing function that's been defined by Mongoose and sub in our own custom implementation. So right now, we're running a little bit of our own logic inside of here, which at present is just the console log. And then immediately after that, we execute the original exec function so that the query runs as expected. Now, before we add in any more logic into this function right here, we're going to go back over to our blogroutes.js file and clean up some of the caching logic that we placed inside of one of those route handlers. So back inside of blog routes, I'm going to find the API/blogs route handler right here. All this logic right now works a-okay, but if we leave it in place right here, it's going to eventually interfere with some of the caching setup that we're going to add into that cache.js file. So we need to clean this stuff up before we go work in that other file. Otherwise, we're going to have some kind of strange conflicts over time. So basically, we just need to restore this route handler to what it was doing before. I'm going to find all the code inside of the API/blogs route handler. I'm going to highlight all of it, so just the stuff inside the route handler, and then I'm going to delete it. So it should be everything down to that client.set line. And then we will replace it with the original implementation, which was simply const blogs is await blog.find _user rec.user.id, like so. And then we'll put in res.send blogs. Okay, so this is what was here before. Before we move on, let's flip over to our browser really quickly and just test out this line of code to make sure that we restored it correctly. So back inside my browser, I'm at the blogs route. I'll refresh the page, and I still get my list of blogs appearing on the screen. Cool. All right, so let's take a break right here. We're going to come back to the next video and start working on our cache.js file to get a more reusable caching solution. Now that we've cleaned up that other request handler, we can start to implement some caching logic inside this exec function that we overwrote right here. The first thing we need to do is think again about our cache key that we're going to use inside of Redis. Now, as a reminder, we had spoken a little bit ago about how we need to figure out some more unique and consistent cache key that will not somehow collide with other collections that we introduce in the future. We had spoken about the presence of a getQuery function. That getQuery function took a query and returned inside of one single JavaScript object all the different ways that that object, or that query, had been customized. So let's now kind of get a more working knowledge of how that getQuery function works. So back inside my code editor, directly underneath that console log that we already have, I'm going to add on one other console log. And inside there, I'm going to run this.getQuery. Now, one quick thing here. Notice how I'm making reference to this. This right here is a reference to the current query that we are trying to execute. So in any way, or like if we think back over to the blog routes file over here, we had made this query right here, and then we eventually executed it. So in this case, if we ran this.getQuery, I would expect to get back an object telling us that we are trying to find a user with some particular ID, because that is the way in which this query right here had been customized. So I'm going to save this file with the console log. I'm going to go back over to my browser and refresh the page. And then we'll check our terminal and see what the result of that console log was. Okay, so I just refreshed it. And now back over here, you'll notice I'm about to run a query, and then it has some information about how that query was customized. You'll notice that these first two console logs are completely identical, and that actually is to be expected. The first console log that you see right here is a request from our React application to get a reference to the current user who is signed into the application. So this query right here is to get the current user of the app. The second request that you see right here is also to get the current user, but it's in the context of making sure that whoever's trying to fetch the current list of blog posts is actually signed into the application. So these are two queries that are completely identical. They're both trying to get details about the current user, but they're being executed at different locations inside of our project. These right here are great examples of calls that we would definitely want to eventually cache inside of our app. You'll then notice that the third query right here is the query that's used to actually fetch our list of books, or excuse me, a list of blogs that belong to the current user. So we're specifying _user, and then the ID of the current user that we want to fetch all blogs for. So this is an example of the getQuery function in action. Now, one other thing here related to generating our more robust cache key, you'll recall that we had said that the cache keys here were supposed to be like our query, right? We were going to take the query and use that as the actual key. We had also said that these needed to be consistent and unique. So by just calling getQuery, that's definitely enough to identify a query that's being issued in multiple copies of it in a row, as we're seeing right here, right? These are consistent query calls. However, we're still not encoding in the actual name of the collection that we're trying to make the query over. So even though these are clearly different IDs right here, we might eventually be trying to issue queries that are identical in all respects except for the collection that they're being executed over. And so we would need to make sure that we somehow also encode the collection name into the key as well. So to get access to the collection name, we can console log out this.mongoose collection.name, like so. So let's save this file and run this inside the browser again. So I'll refresh the page. And then over inside my terminal, now we'll see those query options right here. And then right underneath it, you'll see the actual collection name. So if we combine together the query options and the collection name, we will in fact end up with a cache key that is both unique against other types of queries that are being issued, but also consistent to make sure that if this same query is executed again, it'll recognize or it'll produce the exact same key. For example, again, these two requests right here are fetching the current user. And if we combine this object together with this string and this object with this string, those two keys would be absolutely consistent. So the same exact query yields the same key, but they are different compared to this other query over here. So again, unique but consistent. Okay, so now the last thing I want to show you is how we're going to actually combine those two pieces of information to generate one single key. Okay, so this is the same diagram that we were looking at just a second ago, but I've now taken the key and actually placed it in here. So we're going to take that object that we just saw, like the result of get query. We're going to add in the collection name as a simple collection property, like so. We're then going to take that entire object and we're going to turn it to a string, and then we're going to use that entire string as the key inside of Redis. So that's how we're going to end up with a key that is both consistent and unique. Okay, so that's the plan. We're going to combine that object, that get query object, together with the collection name and then use it as the key. So let's take a pause right here and we'll write out the actual code for that in the next video. In the last section, we saw the result of get query and mongoose collection.name. We're going to use these two properties right here to generate our cache key. And let's do that right now. Now, one thing I want to mention is that we want to combine these two options together, these two things together inside of one object. So you might be thinking, well, let's just take the result of get query right here and add in this mongoose collection.name thing to it. Unfortunately, we can't do that, because if we modify the result of this function call in any way, it will actually modify the underlying function call. And we definitely don't want to do that. So we need to somehow take this get query object, or the object that's returned from it, and make a copy of it, and then also add in the collection name to it as well. To do that, we're going to use a function called object.assign. So object.assign, like so. The first argument to this is going to be an empty object. The second is going to be this.getQuery, and then the third is going to be another object, but this one is going to have collection with this.mongoose_collection.name. And I'm going to delete the console logs right here as well, just for some clarity. Object.assign is used to safely copy properties from one object to another. Oh, and one thing I just noticed here, we want to do get query with parentheses like so. The first argument is the object that we're going to copy a bunch of properties to. So we're going to take the results of get query, we're going to take all the properties that are on there, and we're going to assign them to this empty object. We're then going to take this other object over here that we just formed up and copy this property onto that empty object as well. Again, we're going through this extra step right here to make sure that we don't accidentally modify the object that is returned from get query. Because if we modify that object, we'll modify the actual query itself. And we definitely don't want that to happen. Now for right now, we're going to assign the results of this to a variable called key. And then how about we just console log out key really quickly to make sure that it's working the way we expect. So I'm going to go back over to the application, refresh the page, check my terminal again, and now I can see that I've taken the actual query options and added in the collection property as well. So now these two queries right here that I would definitely want to have served from cache are definitely consistent, but they are also unique compared to this completely different query over here. Now you will recall that I had mentioned that after we create this key, we eventually want to turn it into a string for when we eventually use it with Redis. So eventually we're going to make sure that we JSON stringify this key right here as well when we eventually go to work with Redis, but we'll take care of that in just a minute. Okay, so that's pretty much it for the key. So let's take a pause right now. When we come back, we're going to start to actually implement the main caching logic inside of our exec function. So I'll see you in just a minute. We just put our key together and we're going to make use of it in just a moment. But before we do, I want to get some common setup code inside this file that we had back inside of our route handler just a moment ago. So I'm talking about the logic around creating our Redis client, Promisifying the get function, and so on. So we're going to add that in really quick and then get back to using our key. All right, so at the very top, we're going to require in Redis, and then we'll set it up with our Redis URL. So we'll say const Redis is require Redis. I'll also bring in the util library as well. Remember, we are using that to promisify the Redis get function. I'll then declare the Redis URL variable, which is at redis://127.001:6379. We'll declare our client with redis.createClient and pass in the Redis URL. And then finally, our last little piece of record keeping here, we're going to make sure that we promisify our client.get function. So we'll say client.get is util.promisify client.get. Cool. Okay, so now that we've got all this boilerplate back up here again, let's continue in the next section where we're going to put our key to good use. So I'll see you in just a minute. Now that we've generated our key, we can use it to go through the same caching process that we used before. I'm going to first start off by cleaning up these console logs because we really don't need them anymore. And then I'm going to put a couple comments down just to guide myself. So like I said, this is going to be the same caching process that we used previously, but again, I just want to see the comments so we get some good idea of what we're trying to achieve. So first, we're going to see if we have a value for key in Redis. If we do, return that. Otherwise, issue the query and store the result in Redis. So that's the general idea. That's overall what we're trying to do here. So the first thing we need to do is check Redis to see if we have a value for the key that we just created. Now we've done this a couple times, or at least one time before. So I'm going to define a new value or new variable, and I'm going to call it cache value. So this is essentially the value that we had stored inside of our cache. I'm then going to place the await keyword, and we're going to reach into Redis with client.get, and we're going to ask for whatever value is stored at key. At the end of the last video, you'll recall that I had said that our key needs to be a string, but right now it's an object. And I just realized that in truth, we need to actually make use of this key more than one time. So rather than trying to turn this into JSON, like every time we need to make use of it, let's just turn it into JSON up here just one time. So I'm going to say JSON.stringify, and I'm going to wrap that entire object.assign call like so. You'll also notice that we are making use of the await keyword now. So to make sure that I can make use of await, I'm also going to decorate this function as being async like so. So don't forget the async keyword up here. All right, so this is going to retrieve our cache value. So now that we've got our cache value, we're going to check to see if that value actually exists or if it's null and like doesn't exist at all. So I'll say if cache value, then how about for right now, we just try to console log out cache value and see what we're working with. Otherwise, we want to actually issue the query and store the result. So to actually issue the query, we have to run this line of code right here, which calls the original exec function with whatever arguments were passed to this function. I'm going to remove the return keyword here because we definitely don't want to return the result of this. We want to somehow like let the query happen and then work with the result in some fashion. So I'm going to take the result keyword off, and I'm going to instead use the async await syntax again to get the result of the query. So I'll say const result is await exec.apply. So this will wait for the query to be executed, and then whatever comes back from MongoDB will be assigned to result right here. Now again, before we try to like go too far inside of one video without really understanding what we're working with here, let's console log out result as well and just see what we're dealing with. So I'm going to say console log result like so. Now if we execute this code right here, I'm going to definitely expect to see some errors because we're not actually returning any valuable data from this thing right now. We're just trying to console log stuff. Nonetheless, I do want to execute this code and just see how it's going. So I'm going to save this file, and I'm going to go over to the browser and refresh the page. Now you will probably see some like status 500 errors down here, which is totally fine. Let's open up our terminal and see what we've got. Okay, so again, we see a couple of errors here, like failed to deserialize or anything else, but also right above those errors, you'll see the console log of what was retrieved from MongoDB. So in both cases, I see some information about the current user that we were trying to fetch. Cool, so it looks like we're definitely successfully retrieving data from MongoDB inside the exec function. However, I want you to notice that this is what appears to be JSON data right here. And that's actually kind of relevant. We'll talk about why in just a moment. So let's take a pause right now. We're going to come back in the next video and talk about why we care about the fact that this is JSON data at all. At the end of the last video, we looked at the console log that had been returned from our query, and I had said that it looked like we were working with some JSON data here. However, I want to investigate what value actually got console logged here when we made the query using exec. So just as a reminder, this console log right here is the result of this console log. It's what we get back from running the query itself. Okay, so one thing I want to remind you, and this is why we care about what that return value is at all, is the expected return values that usually come from the exec function. Anytime that we try to monkey patch or overwrite an existing function inside of a library, we have to be very cognizant of what values we are returning, because we never know how that library is attempting to use that function itself. So whenever we call the exec function, the Mongoose library expects that we're going to return a promise that eventually resolves with some Mongoose documents. So even though our console log right here looks like we're working with a plain JavaScript object or just some regular JSON data, this is not actually a plain JavaScript object. In fact, this is a Mongoose document, or what we refer to as a model instance. I can prove that to you as a matter of fact. If we go back to our console log and update it to say result.validate, like so, and then refresh our application one more time, and then check the terminal, you'll notice that the console log is now a function. And obviously that object before did not have a validate function. Only Mongoose documents do. Now the reason that this is a problem at all is that when we start thinking about caching values here, we've got one function that returns a bunch of Mongoose documents, or in this case just one Mongoose document. But when we try to start storing this data inside of Redis, we're not going to be working with smart objects or objects with prototypes or functions or anything like that tied to them. Remember, Redis only stores essentially strings and numbers, essentially for us, JSON data. So we need to be very cognizant of the fact that sometimes this data that we're going to be working with is going to be model instances or documents. And then in some other cases, like when we want to interact with Redis, it needs to be in a JSON format. So let's keep that in mind as we start writing some more code back inside this file right here. So we can return result right here. We can return that right away and everything will work inside of our application as we expect, because result right here is the actual document instance, and that is what is expected to be returned from the exec function. Let's try that right now. I'm going to return result like so. I'm going to save the file, and then if I go refresh the application, you'll notice that everything works the way I expect. So I'm logged in and my blog posts appear on the screen. So we need to make sure that before we try to take this result right here and store it inside of Redis, we need to first turn it into JSON. So let's do that right now. We're going to take result, we're going to turn it into JSON, and then we'll store it inside of Redis. So I'll say client.set. I'm going to set that key that we had produced way up here at the top of the file, so key right here. And inside there, I'm going to set json.stringify result, like so. Okay, so this is definitely now going to take the result that we got back, turn it into JSON data, and then set it inside of Redis at that particular key. So now, if we run our application or we refresh our page again twice inside the browser, we should see one time where we attempt to set this data inside of Redis, and the next time we refresh, we should then see our console log appear, where we are pulling this data back out of Redis. So let's try that right now. So I'm going to go back over, I'm going to refresh one time, so this is going to put our data into Redis, and I'm going to try it one more time, and now we should be attempting to pull it out of Redis. Cool, so looks like that worked out to some degree. Now let's check our terminal down here and just make sure that this console log appeared. Cool, so I see my console log, so this is the data that we just fetched out of Redis. Now you'll notice that our application or everything like still worked the way we expected. That's because inside the if statement right here, we're not attempting to return early. So right now we're still letting the query run on over to the actual MongoDB instance. And when that happens, we're trying to actually return that result rather than returning the cache value early up here. So let's change that right now. Let's return the cached value and not attempt to actually run the code that goes over to MongoDB. So I'm going to say return cache value, like so. And then remember, anything that comes out of Redis is going to be in JSON form. So we need to parse it before we return it from this caching function. So I'm going to say json.parse with cache value like so. Okay, let's give this a shot. I'm going to save the file. I'll go refresh the page. And, well, it looks like something loaded up here, but I didn't actually get any content appear on the screen. So clearly, something is still not quite working the way we expect. Let's take a pause right here. We're going to think if we can't figure out exactly what's happening that's preventing us from actually seeing any content appear. So I'll see you in just a minute. We now have kind of closed the full loop of caching inside of our exec function. So we're handling the case in which we do not have information stored, and we also are handling the case in which we do. However, it looks like any time we attempt to actually return some stored data from Redis from this function, our app doesn't quite work the way we expect. In particular, the app seems to think that we are logged in, but we don't actually have any blog posts. So clearly, something is not working the way we expect. Well, this really goes back to the same topic that we just discussed a moment ago, and it comes down to the return type, or the values that we are returning from the exec function. At present, if we have something stored inside of cache, we are parsing that from JSON into a plain JavaScript object and then returning the result. However, the exec function expects us to return Mongoose documents, or what we refer to also as model instances. So to put it in kind of diagram format, we're in this situation. So right now, we are returning plain JSON data that has absolutely no functions or anything tied to it. It's just the raw data. But the exec function expects us to return a Mongoose model, which has properties like the get function, set, validate, is modified, all the stored properties that belong to that model. So our application only appears to be like half working because it's not getting the type of data that it expects back from that exec function. So we need to somehow take this JSON representation of the model that we have right now and turn it into the actual document that we are expected to return. So that might actually sound kind of challenging, but in fact, it's just one of those things that you got to dig into the documentation to figure out how to do. To show you what we're going to do, back inside of our cache value if statement right here, I'm going to change the console log to be simply this. Now you'll recall that this inside this function is a reference to the query that we are currently executing. So we are going to console log out this, and this is going to be the current query that is being executed. So I'm going to save this file and then run the query again by refreshing the page inside my browser. Okay, so I just refreshed the page. Now I'll go back over to my terminal and you'll see a tremendous number of properties all tied to the current query that was just executed. Now I'm going to scroll through here a little bit, and maybe about 100 lines up or so, I'm going to eventually come across a property called model. Model right here is a reference to the model class that is tied to the query that we are executing. So this model property right here is essentially the base class for a user or a blog post inside of our application. So to take the JSON data that we just pulled out of Redis right here and actually turn it into a document or a model instance that can be used correctly throughout our application, we can call this, new this.model, and then pass in the result of that parse statement, like so. So this.model, again, is a reference to the model that represents this query, or that this query is attached to. We can create a new instance of that model by calling new the model class itself, and then pass in the properties that we want to assign to that model. This is no different than normal, typical, just like normal Mongoose code that we would write, where we might say something like new blog and then pass in a title of hi and content of there. We're doing the same exact thing here. The only difference is that some of the constituent parts look a little bit different. So this .model would be the same as just referencing blog, and json.parse with our cache values would be the same thing as passing in a normal JavaScript object with some set of values. Okay, so that's going to take all the data that we've stored and try to turn it into an actual document. So I'm going to take the result of this right here, and I'm going to assign it to a variable that I'm just going to call doc. And then we will return that rather than returning what we had before. So I'm going to save this file, and let's try testing this out inside the browser. So I'll refresh the page. And well, it looks like we are still logged in, and it looks like the content on the screen is a little bit different, but we definitely still have an error message down here. So it looks like something is still not behaving quite the way we expect. Well, let's try thinking about this for a little bit. So right now, we're taking the result of cache value and passing it into the this.model constructor. Now this is a little bit of a gotcha, so I'm just going to tell you what's going on here. At present, we have two types of values, kind of roughly speaking, that we are storing inside of Redis. We are storing model instances, like our current user that we are fetching, but we are also storing arrays of models or arrays of records, which is the case for our list of blog posts. Whenever we create a new instance of a model, as we are doing right here, the expectation is that we're going to pass in exactly one attribute or one record's worth of attributes as arguments. So whenever we try to take the current user and turn them into a model instance, this line of code right here is working perfectly because this json.parse turns into something that has, like, my ID with my Google ID and whatever else belongs to a single user. However, when we pull out an array of blog posts, the json.parse right here turns into an array of blog posts, each of which need to individually be turned into a model instance. So we made a little bit of progress, but now we need to handle both cases properly. The case in which we are dealing with an array and the case in which we are dealing with a single object. So let's pause right here. We're going to come back to the next video and we're going to update this line of code to handle both the case in which we just fetched a single object or an array of objects. So I'll see you in just a minute. In the last section, we spoke about how we are properly taking our cache value right here, parsing it from JSON, and then creating a new model instance, but we're not properly handling the case in which this cache value right here is an array of records, as is the case whenever we try to fetch a list of blog posts. So we need to do a little bit of a refactor here to handle both cases properly. I'm going to first start off by deleting this entire line of code altogether. We need to do something slightly differently depending upon whether or not we are attempting to deal with an array of records or a single record. So I'm going to first start off by creating a variable called doc and parsing our cache value, like so. I'm then going to remove the return statement, and then we're going to replace this with a ternary expression instead. So a ternary expression has a first kind of check or a Boolean check of sorts. So we're going to check to see if doc right here is an array or just a simple object. So I'm going to say array.isArray and then pass in doc like so. So if doc is an array of records, then isArray is going to return true. Otherwise, it's going to return false. So then to put our ternary expression in, I'm going to put my question mark, and I'll put down the case in which it's true. So this would be like right here, it's an array, a colon, and the case in which this right here is false. So it's an object. And then obviously we don't actually want these words here. So we're going to replace each of these with a little bit of logic. Now because I expect both these statements right here to have a lot of code related to them, I'm going to new line this just to give myself a little bit of space to work with, like so. So let's deal with the easy case first, the case in which we are dealing with an object. So if we're dealing with an object here, we're going to say new this.model and pass in doc, because that's a plain object and it represents one individual record. However, if we're dealing with an array, which is this case right here, we need to map or iterate over this array of doc, and for every record inside that, we're going to call new this.model, and we're going to return a document instance. So I'm going to say doc.map, and then for every document, which I'm going to abbreviate simply as D, I'm going to say new this.model, and then pass in that particular record, like so. So no matter whether we are working with an array of records or a single record here, this entire ternary expression is going to correctly parse, or we refer to this as hydrate, all those values. Now the last thing we need to do is make sure we return the result of this entire ternary expression. So I'm going to add a return right in front of it, like so. Okay, so this looks pretty good. Let's flip on over to our browser and do one more test. So back over inside the browser, I'll refresh the page. And now I properly see my list of blogs appear, and I also appear to be correctly logged into the application as well. Great. So it definitely looks like we've got a working cache set up here. But, there might still be a couple of issues. Let's take a pause right now. We're going to come back to the next video, and I'm going to mention a couple things that we could very easily do to dramatically improve how this caching system works. So I'll see you in just a minute. Our caching setup is working pretty well, but there's still a couple of issues that I want to address. We have implemented all of our caching logic directly inside of the exec function. Remember, anytime any query is issued inside of our application, the exec function will always run. And what that means is that every query is being cached. Now that might be okay for the application we're working on right now, but I can very easily imagine circumstances where we would not want to automatically cache every single query. For example, remember that Redis storage is generally pretty darn expensive. Like storing information in Redis, not the cheapest thing in the world. So if we have an application where we know that we have to be doing a lot of queries that return a lot of information, we might want to make sure that those are not cached, just to save on value of what we're having to pay to a Redis provider. That's just one circumstance, but I bet you can imagine other circumstances as well. So I think that we need to figure out some way to say like, hey, this query over here, this should be cached, but this one over here, no, don't cache this. I'm going to open up my blog routes file inside of my routes directory. And inside of here, I'm going to again find the route that retrieves our big list of blog posts. So here's my thought. I think that we should create a new function that is tied to every query. I think we should call that function cache, and we should call it like so. I think that if this function gets called, then that means that this query right here should make use of our caching system. But if that .cache is not present, so if it's not tied on to the query, then we should avoid the caching system altogether. In other words, by default, we should attempt to not cache anything unless we specifically try to have it cached. I think that would make it very clear, because then an engineer who's looking at our code in the future could very easily look at this query right here and say the query right above it, and they could easily say, oh, okay, this is going to be cached, but this one is not, because this one up here does not have the .cache tacked onto it. So I think that would be a very clear system. The only question is, how do we implement it? Well, that's the hard part. Okay, I'm going to clean up this .cache down here really quick. And then I'm going to go back to my cache.js file. So when I added on that .cache statement, I tacked it on to a query instance. And remember, all the queries inherit, I think is the best word here, all of our queries that we create inherit from this query.prototype right here. So if we add on additional functions to this prototype object, they will be available to any query that we create inside of our application. So to add on that cache function, we would write out mongoose.query.prototype.cache equals function, like so. Now do make sure that you're using the function keyword here, just like we were before. We do not want to be using an arrow function, because if you use an arrow function, it's going to mess with the value of this. So now we need to write some logic in here that makes sure that if we call this function and then later have exec be executed, we make sure that caching will be enabled. But if cache is not called, then when cache is called, we want to skip the caching system. So to do so, we could add in some simple flag to the .cache right here. So we'll say that if anyone ever calls .cache, we will set the value of some random property that we're going to assign on the query itself to true. So I'll do something like this.useCache equals true. Now a couple thoughts here, a couple things I want to mention. First off is the value of this. Remember, this is equal to the query instance. So anytime that we write a query, like we did right here back inside of our blog routes file, this right here creates a query instance. So if we then called .cache on it, that would set the value of this.useCache to true for only this query and no other query inside of our application. Now the property name of useCache, I just made up off the top of my head, just to be clear. So we can call this useCache, or we can call it underscore cache. It's totally up to you, whatever you want to call it. Now we're setting this property on this inside of the cache function, but because the same query instance is referenced from both this cache function and exec, because remember, these are both functions that exist on a single query instance, then over inside the exec function, we could reference this property by just writing out this.useCache, like so. So now we could do a very simple if statement check at the top of exec. We could check to see if useCache is true. And if it's true, we will run all the caching logic that we just added in. But if it's false, then we will skip all this caching logic and simply run the original exec function that does not include any caching logic whatsoever. So to do that, we might add in if this.useCache equals false. And this right here is a little bit more verbose than it needs to be. We could condense this to just be if not useCache. Then we will run the original exec function and return the result of it right away and skip all the other caching logic that we have inside this file. So I would say return exec.apply with this and arguments, like so. Now one more quick thing. Inside the cache function, the idea here is that we could tack this thing on as like a chainable property. So in other words, it'd be really nice if we could do something like, so back inside of my route handler, inside the blog routes file, by the way, it would be really nice if we could do something like .find, .cache, .limit 10, .sort, or whatever other properties. So it'd be really nice if we could just throw this in here and chain it like any other of these chainable function calls that we're used to that are tied to queries. So to make sure that it's an actual chainable function call, we would return this from the function itself, like so. That's all we have to do, and now it's chainable. Okay, so I'm going to go back over to my blog routes file, and I'm going to say that I want to cache this query right here and nothing else inside of my application. So I'm going to make sure that this query alone and nothing else inside my app has the .cache call. All right, so I'm going to save this, and then I'm going to go refresh my application inside the browser. And hey, well, it looks like everything worked the way I expected. Now I can refresh and I still see all my data appear again. Okay, so it definitely looks like, hey, at first glance, maybe it worked, maybe it didn't, I don't know. A very easy way to check would be to create another blog post. Because remember, at this point, we are not expiring any cache values. So if we create another blog post and it does not immediately appear on this list right here, that means that our list of blog posts must be getting cached. So let's do that right now just to test. So I'm going to grab some lorem ipsum text. I'll then make my third blog post. And then I'll save the blog. And now back over on this list right here, I do not see that line or that new blog post appear. However, if I go back over to my application and remove the .cache call, so now I'm going to take it out and then save this file, I should be able to go back over, refresh the page, and now see that third post appear because now I am not making use of caching. Okay, cool, so that looks pretty good. So we've now got this reusable helper that we can tack on to absolutely any query that we make inside of our application to decide whether or not to serve that value from cache. So that's definitely a good improvement, but we still have some issues around expiring cache records and making sure that we can see new data appear after it's been changed inside Mongo. So let's pause right here. We'll we'll continue in the next video and figure out how to add in some better cache expiration to our application. So I'll see you in just a minute. The last thing we have to think about inside of our application is how we expire records inside of our cache. Now there's two ways we can solve this. First off, we've got automatic cache expiration, which we looked at a little bit ago for just a little bit, just to explain very quickly. The other thing that we're going to quickly start talking about, probably in the next video, is how to programmatically expire areas of our cache. Give us the ability to say, hey, this person just created a new blog post. Stop serving them from the cache for at least the next time they ask for a list of posts. So we'll figure out that more complex way in just a second, but first, let's set up some automatic expiration. I'm inside of my cache.js file. Inside of here, I'm going to scroll down towards the bottom of the file and find the client.set call right here. So you might remember that anytime we set a value inside of Redis, we can also, at the same time, set a duration for that value as well. So after some number of seconds, that value will automatically expire and it will be no longer returned from Redis. To do so, I'll add on a third argument of ex and make sure it's capital, and then a fourth argument of the number of seconds that this value should persist inside of Redis. And for that, I'll say just 10 seconds. Now, one thing I want you to be aware of, when I save this file and then refresh the page inside the browser, I would not expect to see my third blog post appear here. This set call, the expiration on it, is only going to apply to future sets that we do. We have already set our cache with at least, for me, 2 records. For you, there might be more, but I've already set a cache value with 2 records inside of here. So setting that expiration time is not somehow retroactive. Until we set this blog post value again, we're not going to see that new value appear. However, if we go create a brand new account and start creating posts tied to that one, well then we will be resetting the cache and this expiration is going to kick in. So all I'm trying to say right now is that if you test this out inside your browser, it might seem like the expiration is not working, but as soon as we start clearing this cache and see this line of code right here run again, then the expiration will kick in. So it's a very temporary issue that is only applicable like right now, so to speak. Okay, so this definitely looks good. Let's take a break right now. We're going to come back in the next video and we're going to figure out how to more programmatically expire areas of our cache. So I'll see you in just a minute. In the last video, we set up automatic cache expiration, but this really does not solve all problems that we might run into around expiring records. For example, adding this expiration of 10 seconds or say 50 seconds or whatever we might want it to be really doesn't solve the problem where we look at a list of blog posts, create a new post, come back to this list, and then expect it to appear. Remember, your user is going to expect data to automatically appear on the screen, and they will not want to wait for some cache expiration to kick in. So we clearly need some way to programmatically or like forcibly kick wide areas or tremendous amounts of data that is stored inside of Redis. But preferably, we would not do it by just resetting everything inside there. That's definitely not a good solution, because if we have many people creating records inside of our application at the same time, we would not want to blow away our cache for everyone any time a single record is created. So to solve this problem, we're going to go back to one topic that we spoke about when we first started looking at Redis. So first, let me give you a quick reminder of how we are currently storing information in Redis by using a cache key. So at present, we take our query parameters, or kind of whatever ways we have customized a query. We then add in the collection name, we stringify the whole thing, and we use that as our collection key. So in this example right here, you'll see that I have a query to users looking for ID 1, a query to blogs with user of ID 1, and then, so these two right here might be like one user, and then I've got a query over to blogs looking for all blogs belonging to user 2. So these are all kind of like flatly stored, or they're all stored at the root level inside of Redis. So I'm going to show you one possible way to solve our issue here. I'm going to show you one possible way to very easily reset kind of like a slice of our cache that belongs to a single user. Now the reason I say this is one particular way is that the application I set up just happened to easily fit into this kind of methodology of killing a section of cache. But you might work on a project of your own where this methodology will not quite work out. Okay, so I just want you to keep that in mind. this is kind of something about caching to keep in mind in general, is that caching from project to project is always going to change slightly. Just be aware of that. Okay, anyways, let me show you what we're going to do here. So I'm going to propose that we re-implement our cache storage schema. And we say that rather than implementing like a completely flat data store where we have just simple key value pairs, we should instead store all of our data for each user in separate nested hashes. So maybe at the very top level, we have a bunch of keys organized by different user IDs inside of our application. So this would be the key for ID, user with ID 1. We would only store the ID here. I only put in user ID just to make sure the 1 had some meaning. So I'm going to change that to 1 now. And this would be like user with ID 2 right here. And then nested inside that would be all the different cache values that belong to that particular user. Now this would be very convenient for our current setup because now anytime that some user creates a new blog post, I could very easily look at all the keys that are associated with the user who just created that blog post and blow away all the nested values that are assigned inside of here. So if user with ID 1 creates a new blog post, I could take all their records that are stored inside of here, or all the records stored inside of Redis, and just delete them all. So now user with ID 2 still has all their cache intact, and we haven't touched that at all. But user with ID 1 is going to have to retouch the database for all the different queries that they need to make. So in other words, they're going to get fresh data directly from MongoDB. So I think you can kind of imagine why this is a solution that really just works on this app, and maybe some others, but it really comes down to a particular app thing. For example, let's imagine that the user with ID 1 right here could also create blog posts that are visible to user 2. Well, if user 1 then create a new blog post, we would have to delete all of their cache and then also somehow figure out that we need to say, okay, this person, user ID 1, also can show blog post to 2, so we need to make sure that we blow away their cache as well. Now it's kind of a contrived example, but I think you can imagine that as soon as there's a little bit more dependencies between data, this strategy might not quite work out so well. So again, all I'm really trying to say here is that before you use exactly this strategy on your project, kind of think about how you're going to actually implement it. Okay, so let's pause right here. We're going to come back in the next video and we're going to start to implement this kind of nested strategy and then figure out some way to easily blow away an entire section of our cache. So quick break and I'll see you in just a minute. In the last section, we spoke about using user IDs as our top level hash keys that would allow us to better organize information stored inside of Redis. So let's now refactor our cache file and make sure that we are making use of this different schema. Now, as we do this implementation, I'm going to show you how to use any type of arbitrary value. So I'm going to assume that on your own personal projects, you might not want to use a user ID as that top level key 100% of the time. So we are going to instead allow ourselves to more dynamically specify that top level key on the fly. So we don't have to use a user ID at all. We could instead say use a blog post ID if we're trying to record, say, comments that have been cached against a particular blog post or whatever. So let's give this a shot. We're going to make sure that anytime we call this cache function right here, we have to specify some top level hash key to use for this caching operation. So that's what's going to allow us to get some level of reusable code out of this so that we won't be 100% pigeonholed into always using a user ID. So we are going to assume that anytime someone calls the cache function, they should also pass in an options object. I'm going to make sure I default the value of the options object to be an empty object, just in case someone does not pass in anything to it. And then we are going to assume that on this options object, whoever's making use of this caching thing is going to provide a key property. So this is the key that's going to be used as the top level hash key. So that's how we're going to make this reusable for your own projects. So I'm going to take this .hash key and assign the value from options.key. So if you pass in a key property, that's what we're going to use as the hash key. Now, a couple of things to keep in mind here. Hash key, I just made that name up. We don't have to call it hash key. It can be like, hash key to use or whatever you want. So I'm just saying that if you pass in a key right here, I'm going to assign it to hash key so that I could then use it down inside of the exec function when we start setting and getting our data. The other thing to keep in mind is that any key that we use must always be a number or a string. Just to make sure that whenever someone passes in a key value right here, just to make sure that it is a number or a string, we are going to JSON.stringify the number. So if for some reason someone passes in an object for the key property right here, or an array or whatever, we're just going to stringify the whole thing so it can be used as a key. And then finally, I want to handle the case in which someone does not pass in a key at all. So if someone does not pass in a key, I want to make sure that we don't try to use undefined. So if you call cache without passing in a key, this statement right here would end up as undefined. And we probably don't want to use that as a key. So if someone does not pass in a key, and we can check for that by saying or right here, I'm going to use empty string as a key. Now you don't have to use empty string. You could do like default or something like that, whatever you want to use. But empty string is totally fine. Okay, so this gives us a cache key to use for our top level property right here, or top level key, I should say. So now we need to refactor our exec function to make use of our hset and hget functions rather than the set and get that they're currently using. So I'm going to find where we call get right here. So instead of calling get, I want to use hget, which is what we use for pulling information out of a nested hash. And then the top level key that we're going to use will be this dot hash key. Okay, so hopefully now it makes a little bit more sense where we're getting this code reusability. So anytime that we try to cache a value, if you pass in a key property on the cache, on the options object that's going to the cache function, that's going to be what we use as the top level hash key. So it doesn't have to be a user ID, it can be any value you want it to be. Now before we forget, let's also remember to go down to the client.set function. We're going to change this to be hset. As the first argument, we'll pass in the hash key to use. So this dot hash key, like so. And then one last thing that we definitely don't want to forget to do. Remember at the top of the file, we use the Promisify function right here to Promisify the get function. So we're no longer using get. So let's make sure we update this to instead be hget. And then on the other side, we'll do hget as well. Okay, so that looks good. So now we should be able to just refresh our application and use it as is. We don't have to pass in a top level hash key, because if we don't, we're just going to use an empty string as the top level key. So if I go and refresh the application, you're going to notice that all three of my blog posts appear on the screen because now we are using a completely different space inside of Redis to use as our cache location. So this definitely works as is. But if we do want to use some type of cache key and we want to make sure that all of a user's blog posts are all put into like one single bucket, then I could go back over to my blogroutes.js file, and over here I could find the cache function call and then add in some property to use as the cache key. Now I'm going to do a little bit of a new line here just to give myself space, and I'm going to say that I want all of this user's blog posts to be cached in a key of rec.user.id, like so. And when I save, by the way, it just jumps automatically. So I'm using a top level key of rec.user.id. Okay, so that's pretty much it to cache all of a user's posts on one individual hash object. Now let's try this as well really quick. So when I refresh the page, the first time I refresh, it should be pulling everything out of MongoDB. And then the second time I refresh, it should be pulling everything directly out of Redis instead. Now that's definitely a good place to start. So in theory, we now have this kind of nested data structure, but I still want to be able to make sure that I have the ability to like blow away all of a user's cache data just on the fly if I want to. So let's continue in the next section. We're going to make sure that anytime a user creates a new blog post, we automatically try to delete all the cached data that is associated with their ID. So quick break, and I'll see you in a minute. In theory, we are now storing all of our blog posts inside of Redis, nested on a hash where the key is the user ID. The next thing we're going to do is figure out some way to forcibly clear out that hash. we're going to implement the logic to actually remove the data that sits on that hash key inside of our cache.js file, but we're going to call it from other locations inside of our code base. So let's first change back over to the cache.js file. Inside of here, we're going to define a function down at the bottom of the file and export it. The purpose of this function is going to be solely to delete data that is nested on a particular hash key. So I'm going to go down to the bottom of the file, and I'm going to create and export a new object. So I'm going to say module.exports is an empty object like so. And then on this object, I'm going to define a new function called clear hash, like so. So in theory, we might end up exporting multiple functions from this file besides just this clear hash one. That's why I nested it inside this object. Clear hash is going to take the hash key that we want to delete inside of Redis, and then we're going to add a little bit of logic right here to look into our Redis instance and delete whatever data is stored right there. To delete all the information associated with a given key, we write client.del, and then we pass in the given key. Now, just like before, remember that this hash key right here might accidentally be provided as an array or an object or something like that. So to avoid any type of error, we're going to pass in that hash key after stringifying it. So we'll say json.stringify hash key, like so. And that's pretty much it. So now we can import this object, including the function that is nested on it, into any other file inside of our project. We can then call clear hash, pass in the key that we want to delete, and it should clear all the data that is stored at that particular key. In particular, for our application as it stands right now, if we pass in a user's ID, it should automatically clear all the data that is stored on their little nested hash container thing. Okay, so let's give this a quick test. I'm going to flip on over to my blog routes file. And then at the top, I'm going to import that function that we just created. So I will say const clear, what do we call that thing? Clear hash. And we're going to require that from up1 directory services cache, like so. Now I want to clear a user's cache after they create a new blog post. So I'm going to go down to the route handler that deals with post requests to create a new blog post. So I'm going to go down, here we go, right here. So this is where we attempt to save our blog post and then send a response back to the user. So after we send that response, we're going to kill their entire hash key, all the data that is stored inside of Redis that is associated with this particular user. We're going to refactor where we actually do this clearing of the cache in just a second. So for right now, I'll just say that, hey, at the very bottom, after everything else is done, let's go ahead and try to clear out that information. So down here, I'll call clear hash, and I'm going to use the user ID as the key that we're trying to delete. So I'll say rec.user.id, like so. Okay, so let's give this a shot. Now to make sure this is working, we should be able to create a new blog post and then come back to this blog's route and immediately see the new post appear on the screen. That's how we're going to be able to know that yes, it did in fact work. So I'm going to get my lorem ipsum text again. I'll create a new post. I'll say my 4th blog post. I'll enter in my content. I'll do next. I'll save the blog, and then I should see it automatically appear as the 4th one, and I definitely do. Let's try refreshing really quick just to make sure that that sticks around, and yep, it definitely does. Cool, so this looks pretty good. Let's take a break right here. We're going to continue the next video, and I'm going to show you one last change that we're going to make that is going to make this clearing of our hash data or our cache data a little bit more automatic than it is right now. So quick break, and I'll see you in just a minute. We've now got this clear hash function right here that can be used to clear out some area of our Redis cache. Now, anytime someone makes a post request to our API/blogs route, we're going to make sure that we just dump all the information that is tied to them after the blog post is successfully created. However, there's just one thing I want to point out here. I don't know about you, but having to remember to write this line of code anytime that I want to expire some area of my cache is probably going to get a little bit tiresome pretty darn quickly. So in this video, we're going to do a little bit of refactor to make this process right here just slightly more automatic. So I'm going to delete this line of code because I don't want to have to write that out inside of every request handler that I put together. Instead, I'm going to go up to this route handler definition, and inside of here, you'll notice that the second argument to the route handler itself is a middleware. Remember, middlewares can be used to kind of automate certain effects as a request comes into our application. So I'm kind of thinking, you know, every single time we create a blog post, we are always going to want to dump all the cache that is associated with that user. So maybe rather than putting some like distinct line of code inside the request handler itself to clear our cache, maybe we should instead make a middleware that automatically deletes all of the cache associated with a given user. So then if we have any other request handlers like this blog post one right here, where we always want to dump the cache after the request is complete, we could use that middleware to do it for us, as opposed to having to actually write out that line of code in the request handler. So let's give that a shot. We're going to first set up the middleware inside of our middlewares directory. So here's the middlewares folder. I'm going to make a new file inside there called cleancache.js. Inside this file, we're going to require in that clear hash function we just put together. So clear hash is going to be required from services cache. And then we will create a new function and export it. So this function is going to be the middleware that's going to be ran automatically for us. Module.exports, rec, res, and next. And we'll put together the function body. Now there's just one thing here. Anytime we make use of middleware inside of an application, the assumption is always that the middleware is going to run before the request handler. However, when you start thinking about our blog post creation thing right here, we really don't want to dump our cache until after the blog post has been successfully created. So if the blog post is created successfully, great, dump the cache. But if it's not, well, maybe we want our cache to stick around. You know, there's no reason to dump the cache if there's some error with the blog post, like maybe it's not formatted correctly or there's some validation error tied to it. So if there's some tiny error like that, we probably don't want to just automatically dump the cache every time. In other words, I think that we need to figure out some way to allow the request handler to run, and then after that, then run the middleware itself. Now there's just one little problem. The way that Express is wired up, it does not allow us to easily insert additional middleware after a request handler, like the one we have right here. If we added in a middleware to run after this request handler, the handler itself would have to accept the next function, which calls the next middleware in the chain, and then somewhere in the function body, or the route handler body, we would eventually have to call that next function. And this definitely does not solve any issues for us either, right? This is a pain in the rear as well. So instead, we're going to use a little trick. Back inside of my middleware file, I'm going to say await next, and I'm going to make sure that I mark this function as being async. So what this does is it makes sure that we call the next function, which is in this case the route handler, and we let the route handler do everything that it needs to do. And then after the route handler is complete, execution is going to come back over to this middleware right here. And at that point in time, then we will do our work, which is to call clear hash and pass in rec.user.id, like so. So this is going to allow the route handler to run first. We're going to wait for that to execute. And then after it's all done, we will then clear our cache. Okay, so let's give this a shot. We need to import this middleware back into our blog routes file. So back inside of blog routes, up at the top, I'm going to replace the clear hash import statement with a, let's see, what do we want here? We want clean cache from middleware's clear or clean cache. And then down inside of our route handler for creating a blog post, after checking to make sure that the user is logged in, we're going to wire up clean cache and then the request handler. Okay, so this is way more automatic than it was before. And we don't have to put in any like laborious thing in here like, oh yeah, make sure that you clean the cache. It's just going to happen automatically for us after the handler has been executed. Okay, so let's test this out inside the browser now. So I'm going to go back over, I'm going to refresh the page one time just to make sure everything still works. And then I'm going to create a new blog post. So I'm going to get my lorem ipsum text. I'm going to enter in my title. Next, save blog. And then if I scroll down to the bottom, I should automatically see my 5th blog post appear on the screen. And I definitely do. Great, so this is looking pretty good. Okay, so that's pretty much it for caching inside of our application. We definitely learned a lot along the way. The thing I want you to keep in mind with this entire caching setup is that caching really varies based on the project that you're putting together. So my hope here is not that you're just going to take our code that we put together and copy paste it directly over to your project. Instead, I would really prefer that you kind of think about the design of your cache ahead of time and decide whether or not some of the methodologies we used are applicable for your own personal project. We still have a lot to learn about a lot of advanced node topics, so let's take a break right now and continue in the next video with our next topic.